Hello there, and welcome to the Drift to the Stars. I'm so glad you found your way here tonight. Wherever you are right now lying down, wrapped in something soft, the day finally behind you, you've chosen a quiet kind of gift for yourself. A little time to let your mind wander somewhere gentle, somewhere vast and unhurried. Tonight, we're going to spend a long while with planets. Not in the way of textbooks or tests, but in the way of sitting beside someone who loves them, who finds in them a kind of peace, and wants to share that with you slowly, without any rush at all. And just before we begin, if these calm, curious explorations help you unwind, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, if you're ready, let's begin. Picture yourself floating. Not falling, floating, weightless and still, somewhere above the clouds, above the weather, above everything you've ever stood on. And there, below you, is a sphere, small enough that you could frame it between your hands if you stretched them out, quietly blue, softly lit on one side, trailing into shadow on the other. That sphere is Earth. That is where your body is right now, even as your mind drifts upward to look at it. From space, Earth doesn't announce itself. It doesn't glow with importance or hum with the weight of everything happening on its surface. It simply hangs there, in the dark, surrounded by nothing. A small blue drop in an enormous black ocean. Astronauts who have seen it this way, and there have only ever been a few hundred of them, often describe something they didn't expect. Not excitement, not triumph, something quieter. A tenderness, an ache, as if seeing the whole world at once made them feel how much they loved it. You are on that sphere right now. Your weight is pressing gently into whatever is beneath you. The planet is holding you. It has always been holding you, without effort, without pause, without a single moment of letting go. There is something deeply settling about that. You don't have to do anything to be held here. You simply are, and the planet, enormous and ancient and unhurried, simply continues. Now let your sense of scale shift gently, the way light shifts at the end of an afternoon. Somewhere beyond the asteroid belt, past the rust-colored worlds and the pale wanderers of the inner solar system, there is a planet so large that it changes the way you understand the word large. Jupiter. If you could hollow it out and pour the other planets inside every single one, Mercury and Venus and Earth and Mars and Saturn and Uranus and Neptune, all of them together they would fit, and the space remaining would still be considerable. It is not a planet the way Earth is a planet. It has no solid ground. There is no surface to stand on, no place where the air ends and the rock begins. It is layer upon layer of gas and cloud and pressure, descending so deep that the hydrogen at its core may be compressed into something that conducts electricity like metal, a planet made of weather, all the way down. And yet, for all its immensity, Jupiter spins faster than any other planet in the solar system. A single day there lasts less than 10 hours. Something that enormous, rotating that quickly. The clouds at its equator are dragged into long, curved bands by that spin pale cream and deep amber. Ancient storms embedded in them, like knots in old wood. Scientists still aren't entirely certain what lies at Jupiter's very center. The pressure there is beyond anything we can recreate. It may be a small rocky core. It may be something we don't yet have a name for. And quietly, without asking anything of us, it turns. There is a kind of time that belongs to other worlds. Not the time of clocks or calendars, but the slow, orbital time of a planet moving through space on its own unhurried path. Mercury lives by a very different clock than we do. It moves around the sun quickly, faster than any other planet, pulled along by gravity in a tight, close arc. One full journey around the sun takes only 88 of our days. A year on Mercury is shorter than a single season here, but here is the quiet strangeness of it. Mercury rotates so slowly on its own axis that a single Mercury day sunrise to sunrise takes longer than a Mercury year. By the time the sun has crawled from one horizon to the other and risen again, Mercury has already looped entirely around the sun, twice. Time, it turns out, is not a fixed thing. It is shaped by gravity and rotation and distance. It bends and stretches differently depending on where you are. Our sense of a day, the reliable rhythm of light and dark that structures almost everything in human life, is simply the particular speed at which this particular planet spins. Somewhere else, it is different. Somewhere else, a single day contains an entire year. There is something oddly freeing in that. The pace we live at is not the only pace, not the right pace, just ours. And even that is slowly, almost imperceptibly, changing, the days growing longer by fractions of a second over millions of years, the planet gently winding down, like something resting after long effort. Cold does something to sound. It slows it, thickens the air, or thins it, depending on the kind of cold. And in the very far reaches of the solar system, where Neptune moves in its long, patient arc, the cold is of a kind that has no easy comparison to anything we experience on Earth. Yet Neptune is not a still or silent place. Quite the opposite. The winds on Neptune are the fastest of any planet. They tear around the planet at speeds that would strip a landscape bare in seconds, invisible and relentless, driven by some internal heat source that coasts Neptune. Because Neptune gives off more warmth than it receives from the sun, and no one is entirely certain why. A storm called the Great Dark Spot was observed when Voyager 2 flew past. It was a vast, swirling absence in the blue, like a bruise in the atmosphere. And then, years later, when the Hubble Space Telescope turned toward Neptune, it was gone, vanished. A storm the size of Earth simply dissolved, and a new one had appeared elsewhere. Neptune does this quietly, without record or announcement. Its atmosphere shifts and reforms on its own terms, in the dark and cold, attended by no one. And yet, through all of this, through those shrieking winds and those enormous disappearing storms, Neptune itself moves slowly. It takes 165 years to complete one orbit around the sun, raging inside, patient outside. There is something deeply familiar in that particular combination. Somewhere in the solar system, a planet spins so slowly that if you stood on its surface, you would age an entire Earth year before the sun moved meaningfully across the sky. Venus, the second planet from the sun. From a distance, it is radiant, the brightest object in our night sky after the moon. A soft, steady light that has guided sailors and inspired poets, and been mistaken for something extraordinary more times than history can count. And it is extraordinary, just not in the way its gentle glow suggests. A day on Venus, one full rotation on its axis, lasts longer than a Venusian year. The planet completes an entire orbit around the sun before it finishes turning once. You would watch the sun rise, and before it had set, Venus would have already traveled all the way around the sun and returned to where it started, and it rises in the west. Venus rotates in the opposite direction to Earth, meaning the sun travels backward across its sky, appearing in the west each slow morning and setting, eventually, in the east. No one knows for certain how Venus came to spin this way. A collision, perhaps, in the violent early days of the solar system, or the slow, patient pull of the sun's gravity gradually reversing what was once a more ordinary motion. What we do know is that Venus has been doing this, alone and unchanged, for billions of years, spinning its long, slow, backward day beneath clouds so thick they have never once parted to show the surface what lies above. There are things in this solar system that seem too delicate to exist, things that make you wonder how the universe arrived at them, whether through intention or pure, improbable chance. Saturn's rings are one of those things. They stretch outward from the planet for an extraordinary distance. If you laid them across Earth, they would reach nearly to the moon. And yet, for all that width, they are almost unimaginably thin. In most places, The rings are less than a kilometer thick, some sections only tens of meters, a structure wider than planets, thinner than some city blocks. If you scaled Saturn down to the size of a basketball and kept the proportions true, the rings would be thinner than a single sheet of paper wrapped around it. You might not even feel them if you ran your finger across. They are made of ice and rock fragments, ranging from tiny grains to pieces as large as houses, each one orbiting Saturn individually. Not a solid disk. A river of separate, silent travelers, each keeping its own pace, each following the curve of gravity as though it were a gentle suggestion. And they will not always be there. They are slowly falling inward, pulled by Saturn's gravity, grain by grain, ring by ring. In a few 100 million years, a long time by human measure, a brief chapter by the solar systems, they will be gone, and Saturn will travel on, ringless, the way it once began. But right now, they are there, pale and still and paper-thin, one of the quietest, beautiful things in the known solar system. On a planet not very different from Earth in certain ways, similar tilt, similar seasons, a day only slightly longer than ours, there is a mountain so tall it exists in its own atmosphere. Olympus Mons on Mars is a volcano, but the word volcano barely contains it. It is nearly 3 times the height of Mount Everest, so wide that if you stood at its base, you would not be able to see the summit. It would be beyond the horizon. And if you stood at its summit, the base would also be invisible, curving away below you on all sides, hidden by the sheer size of the thing you were standing on. Its peak reaches above most of Mars's already thin atmosphere. If you climb to the top slowly, in whatever distant future that might become possible, you would be standing in something very close to open space. The sky above you would be nearly black. The stars would be visible in the thin, pale margin of air remaining. And it is an ancient thing. Much of Olympus Mons formed billions of years ago. Mars, unlike Earth, does not have shifting tectonic plates. The crust doesn't move. So when a volcanic hotspot released lava, it kept building on the same spot, century after century, piling upward without ever being carried away. The mountain grew because nothing stopped it. Height as the consequence of stillness. There is something in that worth sitting with quietly. Somewhere above you right now, above the ceiling, above the clouds, above the thin shell of atmosphere that holds all of this, there is nothing. And then, further out, there are worlds. But here, on this particular world, something happens that does not happen anywhere else we have confirmed. Water evaporates from the surface. It rises, cools, gathers into clouds, and then falls again as rain. It flows downhill, collects in rivers and lakes and oceans, and then evaporates again. It has been doing this for billions of years, the same water molecules cycling endlessly through sky and ocean and soil. Some of the water you have drunk in your lifetime may have fallen as rain on a Cretaceous forest, may have moved through the body of something ancient and enormous, may have drifted as vapor over a sea that no longer exists. This cycle, the water cycle, as it's plainly called, though the name barely captures what it is, makes Earth unlike anywhere we have found. It keeps the surface temperature stable. It moves nutrients through ecosystems. It carves canyons over millennia and fills the air with the smell before rain. Even as you rest right now, somewhere on Earth it is raining. Somewhere, water is rising. Somewhere, clouds are quietly forming over a dark ocean, unhurried and precise, doing what they have done since long before anything was here to notice. The planet breathes water, slowly, without rest. There is a planet in the outer solar system that moves through space like something that has given up on doing it the usual way. Uranus rolls. While every other planet spins upright or close to it, Uranus is tilted so severely that its axis lies nearly parallel to the plane of its orbit. It doesn't spin like a top the way Earth does. It rolls along its orbital path, more like a ball being pushed slowly across a table, than a planet following its ancient routine. The result is a world of extremes. Each pole faces the sun for 42 years, bathed in continuous daylight. Then, as Uranus rolls through its orbit, the same pole tips into shadow for another 42 years of unbroken night. The seasons there last decades. Winter and summer are not events that come and go in months. They are long, patient states of being, each one outlasting a human childhood. No one knows with certainty how Uranus came to be this way. The most widely accepted idea is a collision, something enormous, striking the young planet and tipping it over in the solar system's early, violent age. A single event, billions of years ago, that changed the direction of everything that followed. Uranus has been rolling on its side ever since, quietly tilted, doing something different, moving through the solar system in its own particular way, neither asking permission nor offering explanation. There is a quiet kind of dignity in that. The warmth on your skin on a sunny day traveled a long way to reach you. It left the surface of the sun already ancient by the time it got there, having spent nearly 1 million years making its way from the sun's core outward through layer after layer of plasma, and then it crossed the distance between the sun and Earth. That journey took 8 minutes. 8 minutes of traveling at the fastest speed anything in the universe can travel, crossing a distance so large it would take a car, driven without stopping, thousands of years to cross. And then it arrived and landed on you. When you feel sunlight on your face, you are feeling something that has been traveling since before you woke up this morning, since before you sat down for breakfast. The light touching you right now left the sun, while you were still in an earlier part of your day, or perhaps still asleep. The sun is not as immediate as it seems. There is always a small delay, a gap between the burning and the warming, between the source and the feeling. You never experience the sun as it is right now, only as it was 8 minutes ago. And the stars you see at night are further still years, centuries, thousands of years behind what they actually are in this moment. You are always, in a sense, looking into the past. Even the light finding your closed eyelids right now, if there is any, carries a little history with it. A small, quiet journey folded inside something as ordinary as warmth. There is a small, cold world at the edge of the solar system that carries something unexpected on its surface. A heart, not a metaphor, a literal shape. A vast, pale region on Pluto's surface, roughly the shape of a heart, so large it is visible from space. It was one of the first things scientists noticed when the New Horizons spacecraft made its long journey past Pluto in 2015, after traveling for 9 years across the outer solar system. The first image it returned showed a world wearing something that looked almost like tenderness. The heart is made of nitrogen ice, slowly churning in a process scientists are still working to understand. It is not entirely stable. It shifts, almost imperceptibly, over time, a glacial movement in the most literal sense. Thick ice flowing like something between solid and liquid across the basin it fills. Pluto is cold in a way that is difficult to hold in the mind. The kind of cold where nitrogen, a gas that makes up most of the air you are breathing right now, freezes solid on the ground. Where the atmosphere itself collapses and settles as frost in the long winter months of Pluto's 248-year orbit. And yet, there is that shape, that pale, unmistakable form on the surface of the most distant world we have visited. Scientists named it informally, almost immediately, with a name that has stuck, Tumbor Regio. But everyone who has seen the image simply sees a heart. The universe does not intend these things. And yet, there it is, quietly, on a frozen world no human eye will likely ever see directly, still shaped like something we recognize. Somewhere in the outer solar system, past the rings and the storms, and the ancient frozen moons, a planet drifts that is less dense than water, not slightly less dense, significantly. If you could find an ocean large enough, a body of water the size of a small star, and you place Saturn gently into it, Saturn would float. It would sit there, vast and ringed and golden pale, bobbing in the cosmic sea like something that had no business being that large and that light at the same time. Saturn is made almost entirely of hydrogen and helium. There is very little of the heavy material that gives rocky planets their weight. It is, in a sense, a planet made of almost nothing, an enormous whisper of gas held together by its own gravity, spinning quickly and quietly in the outer dark. And because of that, because of its low density and its distance from the Sun, Saturn has a kind of presence that feels different from the other gas giants. Jupiter is heavy and dominant. Saturn is vast but somehow airy. Its colors are softer, pale golds and creams, hazy bands that blend into one another without hard edges. Its rings give it a stillness that Jupiter, with its swirling storms, does not have. There is a gentleness to the way Saturn exists. It does not demand attention. It simply hangs in its region of the solar system, enormous and pale and light, turning slowly in a ring of ice, a planet that would float. There is something almost restful in that image, something that makes it easier, somehow, to let your own body feel a little lighter. You might think that between Earth and the Moon there is simply distance, a gap, space to be crossed by rockets and time and fuel. But that gap is larger than it first sounds. If you gathered every planet in the solar system, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and arranged them side by side in a line, they would fit between Earth and the Moon. All of them, placed edge to edge, with a small margin remaining. The entire collection of worlds in our solar system, nested in the space between us and our nearest neighbor, the Moon, which looks so close that you feel you could almost reach it on a clear night, is actually quite far. Far enough that the journey there took astronauts 3 days. Far enough that the distance surprises almost everyone when they first encounter it properly. And the planets, which feel so distant that they require years of travel to reach, are all small enough together to fit inside that familiar gap. Scale in the solar system is like that, constantly folding back on itself in ways that quietly undo your assumptions. Something near is farther than you thought. Something vast is smaller than you expected. Everything rearranges when you look at it carefully. Even as you rest right now, the Moon is out there, perhaps visible through a window, perhaps hidden by clouds, perhaps on the other side of the world, from wherever you are, patient and close, and, in the long view of things, slowly, gently leaving. There is a quality to Mercury's nights that seems almost contradictory, given everything you might expect. Mercury is the closest planet to the Sun. It receives more direct solar radiation than any other planet. In the long, slow daylight of its surface, temperatures climb to extremes that would reduce most materials to vapor. The sunward side bakes in silence, airless and exposed, the rock absorbing heat with nothing to moderate it. And then Mercury's slow rotation carries that same surface into shadow. And with no atmosphere to hold the warmth, no blanket of air to trap the heat the way Venus does, the way even thin-aired Mars does, the temperature plunges dramatically. The nights on Mercury are among the coldest in the solar system, dropping to temperatures colder than Pluto on certain days. The same rock that was scorched in the sun is now, hours later, bitterly cold. The most extreme daily temperature range of any planet. Not because Mercury is particularly strange, but because without an atmosphere, there is nothing to even the experience out. No transition, no holding of warmth. The sun gives, and then the sun is gone, and the rock remembers nothing of what it just received. Our own atmosphere, so thin when seen from space, so seemingly fragile, does something remarkable. It smooths the days. It holds a little warmth into the night. It makes the experience of a day on Earth something livable, something gentle, compared to what airless worlds endure. You are breathing that atmosphere right now, slowly, without noticing. It is doing its quiet work, as it always has. In the southern hemisphere of Jupiter, there is a storm that has been spinning since before the United States existed as a country. before the French Revolution, before most of the music you have ever loved was written. The Great Red Spot. An anticyclonic storm, meaning it rotates in the opposite direction from a hurricane wider, at its largest recorded size, than the diameter of Earth. A storm so persistent that astronomers have been observing and recording it for over 300 years, and it may have been spinning long before anyone thought to write it down. No one knows precisely why it has lasted so long. Jupiter's atmosphere, unlike Earth's, has no solid surface beneath it to disrupt and eventually dissipate a storm. There is no land for a hurricane to run aground on. The storm simply continues, feeding on the temperature differences between Jupiter's atmospheric layers, self-sustaining in a way that nothing in Earth's weather system manages for more than a few weeks. It has, however, been slowly shrinking. It was once much larger, large enough in earlier centuries to contain several Earths side by side. Now it fits only one. Scientists watch it with a kind of careful attention, uncertain whether it is simply cycling through a smaller phase or whether, after all these centuries, it is finally beginning to wind down. Either way, it is still there, still turning. A storm older than most of the things you consider ancient, still spinning quietly in the amber bands of a planet that has never once asked us to pay attention. On clear evenings, if you look toward the horizon just after sunset or just before sunrise, you might see it a steady, brilliant point of light that does not flicker the way stars do. That is Venus, and it is one of the most misleading things in the sky, because Venus, up close, is not what its gentle glow suggests. Its surface is hot enough to melt lead, not metaphorically literally. If you placed a block of lead on the surface of Venus, it would pool into a liquid almost immediately. The temperature there is hotter than Mercury at its peak, despite Venus being nearly twice as far from the Sun. The reason is its atmosphere thick, crushing, composed almost entirely of carbon dioxide, with clouds of sulfuric acid drifting through it. That atmosphere traps heat the way a sealed greenhouse does, and the temperature stays high regardless of day or night, regardless of season. The pressure at the surface is roughly 90 times what you feel right now. The few spacecraft that have landed on Venus survived for only a short time before being destroyed by the heat and pressure. And yet, from here, it glows, soft and constant. The evening star, the morning star, the light that sailors used to navigate and poets used to feel something tender about. Its beauty is entirely real. It reflects sunlight better than almost anything else in the solar system. It is a good reminder that surfaces and appearances are not always the same thing, that something can be genuinely lovely and genuinely harsh at once, and that the distance between you and it is sometimes what makes it beautiful. Every planet has a particular quality of light. Earth has gold and blue. The Moon has silver. Jupiter has amber. And Mars has something that, if you were to stand on its surface at the right moment, would feel strangely like home, and then immediately remind you that you were somewhere else entirely. At sunrise and sunset on Mars, the sky turns blue. Not the same blue as Earth, a paler, more subtle shade, tinged at the edges with something almost lilac. It happens because Martian dust fine, suspended particles of iron oxide scatters light differently than Earth's atmosphere does. On Earth, molecules scatter blue light, giving us blue skies and warm sunsets. On Mars, dust scatters red light, giving pink and copper skies through the day. But at the horizon, at the precise angle of sunrise or sunset, the remaining light that reaches your eyes has passed through so much dust that only the blue survives. So Mars has blue sunsets, quiet, cool lavender blue horizons, fading into a pink and dusty sky above. Scientists have seen this in images from rovers, these lonely machines on a distant landscape, cameras pointed toward a sun that appears smaller and paler than the one we know, the sky around it shading into something that looks almost peaceful, something that might, for just a moment before you remembered where you were, feel like evening somewhere you had been before. familiar and foreign at once, like a memory that isn't quite yours. There are things in the universe that change so slowly they seem permanent, and things that seem permanent but are quietly, consistently moving. The moon is one of the latter. Every year, the moon moves a little further from Earth, about 1.5 inches, roughly the rate at which your fingernails grow. It is not noticeable in a human lifetime. It is barely noticeable across many human lifetimes, but it is real, and it is steady, and over the long span of geological time, it adds up. When the moon first formed, likely from a collision between the early Earth and another large body, a violent event billions of years ago, it was much closer. Close enough that the tides it raised were enormous, close enough that it appeared vastly larger in the sky than it does now. It has been drifting outward ever since, pulled by the same tidal forces that it exerts on Earth's oceans, gradually transferring energy from Earth's rotation into its own orbit. The moon leaving is also the reason Earth's days are growing longer. As the moon drifts away, Earth's spin slows, fractionally, year by year. In the very distant future, the day and the month will be the same length, Earth and moon, locked face to face, turning together in synchrony. But that is billions of years away. For now, the moon is where it has always seemed to be, familiar and round and perfectly sized to cover the sun during an eclipse, one of the most precise coincidences in the solar system, and one that will not last forever. Right now, it is exactly where it needs to be, before a single telescope was pointed at the sky in the right direction, before anyone had seen the faint blue disk of Neptune through an eyepiece. A man sat at a desk and calculated where it had to be. Urbain Le Verrier, a French mathematician, studied the strange wobbles in Uranus's orbit, tiny deviations from where it should have been, and concluded that something was pulling at it, something unseen, at a specific location in the sky. He calculated the mass of that something, and the angle, and the distance, and then he wrote a letter to an astronomer in Berlin and told him where to look. The astronomer looked, and within an hour, he found Neptune less than 1 degree from where Le Verrier had predicted. A planet discovered by mathematics, pulled into existence, in a sense, not by a telescope but by a pencil, and a mind patient enough to trust what the numbers were saying. This is one of the quieter triumphs of science. Not a dramatic discovery, not a lucky accident, but a slow and careful reasoning toward something invisible. An act of imagination grounded so firmly in observation that it reached across the solar system and touched something real. Neptune had always been there, of course, vast and cold and blue, turning in its distant orbit, entirely indifferent to whether we had noticed it. It didn't need us to find it. But something in the finding, the idea that thought alone could locate a world, says something worth holding on to. That careful attention, in the right direction, can reveal what was always there. There is something quietly extraordinary about the names on Uranus. Every other planet's moons are named after figures from mythology, Greek and Roman gods, titans, nymphs. The convention across the solar system is ancient names for ancient objects. But Uranus, in its particular tilted solitude, follows a different tradition entirely. Its 27 known moons are named after characters from the plays of William Shakespeare and the poetry of Alexander Pope, Titania and Oberon from A Midsummer Night's Dream, Ariel and Umbriel and Miranda, Caliban and Sycorax from The Tempest, Puck, small and quick, named for Shakespeare's mischievous spirit. Even Belinda, a character from Pope's mock-epic poem, The Rape of the Lock. Literary names, human names, names that came not from ancient mythology, but from the imagination of specific writers, in specific rooms, on specific evenings, centuries ago. The person who established this tradition was William Herschel's son, John, who continued his father's astronomical work and decided that since Uranus itself had been discovered by his father, rather than by mythology, its moons deserved a different kind of naming, something more recent, something that reflected not the ancient world, but the human one. And so those cold, distant moons, irregular shapes tumbling in the dark around a tilted planet, carry the names of fairies and spirits and complicated, fully human characters. They carry literature into the outer solar system. They carry the quiet proof that wherever we look, we bring ourselves along. Lean into whatever is beneath you for a moment. Feel the weight of your body pressing down, the solidity of the surface holding you. That solidity, that sense of substance and ground, is something the solar system mostly does not have. Most of it is nothing. Between the planets, between the moons, between the asteroids and the comets, and the distant drifting bodies of the outer reaches, there is space. Vast, uninterrupted, almost perfectly empty space. If you shrank the sun to the size of a grapefruit and placed it on a table, the nearest planet, Mercury, would be a grain of sand about 3 meters away. Earth would be another grain of sand, roughly 8 meters from the grapefruit. And Neptune, the outermost planet, would be a small pea nearly 1/4 kilometer distant. Everything in between would be nothing. No air, no dust, no sound. Just the invisible pull of gravity, lacing the whole thing together across distances that are nearly impossible to feel. We think of the solar system as a place full of things, planets and moons and rings and storms, and it is full of those things. But they are islands, tiny, improbable islands, in an ocean so large that the islands themselves barely register. The emptiness is not cold or hostile. It is simply what space is. The natural state of the universe is spaciousness. Matter is the exception. Worlds are the exception. The fact that you are on one, solid and breathing and held, is the surprising part. The ordinary thing would be to be nothing at all, floating in the dark between worlds. The extraordinary thing is this being here, being somewhere, being held by something real. On a moon of Saturn, in the northern hemisphere, there are lakes, real lakes, with shores and depths and something that evaporates from their surfaces on warmer days and falls again as rain. But if you were to reach down and trail your fingers through one of those lakes on Titan, what you would feel would not be water. It would be liquid methane. Cold, far colder than any natural lake on Earth. A temperature at which methane, which is a gas here, condenses into something you could swim through if you could survive the cold and the absence of oxygen and the crushing weirdness of the entire situation. Titan has a thick atmosphere, the only moon in the solar system, with one that is substantial and complex. That atmosphere is mostly nitrogen, as Earth's is, but laden with organic molecules, hydrocarbons, a rich chemical soup that has been building for billions of years. The sky there is orange, the light dim and amber filtered, the surface hidden from above by permanent haze. Scientists find Titan fascinating in a particular way, not because it is hospitable, but because it demonstrates something. Chemistry happens wherever conditions allow it. The ingredients for complexity, for organic molecules, for the long-chain reactions that eventually led to life on Earth, do not require Earth-specific conditions. They arise wherever there is energy and time and the right materials. Titan has been running its own chemistry experiment for billions of years. What it has produced, in those methane lakes and orange skies, we do not yet fully know. Somewhere in that amber haze, something is slowly becoming something else. There is a moon of Jupiter that carries more water than any world we know. Europa, slightly smaller than our own moon. Smooth on the surface, smoother than almost anywhere in the solar system, because what covers it is ice. A shell of ice, kilometers thick, that stretches across the entire globe without mountains or significant craters to interrupt it. Just ice, crossed by long reddish-brown lines, like cracks in old porcelain. Beneath that ice, warmed by the constant flexing and squeezing of Jupiter's immense gravity, there is an ocean, a liquid, global ocean of salt water that has likely been liquid for billions of years. deeper than any ocean on Earth. More water, in total volume, than all of Earth's oceans and ice and groundwater combined. It has never seen sunlight. It is sealed beneath kilometers of ice, in permanent darkness, warmed not by a star, but by the tidal kneading of gravity. And yet, on Earth, we have found life in very similar conditions in deep ocean vents, where no light reaches and the heat comes from the planet's interior. Life that does not need the sun. Life built on chemistry and heat alone. Scientists believe Europa is one of the most promising places in the solar system to look for life beyond Earth. Not life that requires anything like what we have here, just life patient, chemical, ancient, doing whatever it does in the dark beneath all that ice. Somewhere under that frozen shell, in water that has never known daylight, something might be quietly swimming. It is easy to think of the sun as permanent, as the fixed point around which everything else moves, as something that has always been there and always will be. But the sun is a star, and stars are not fixed points. They are processes, sustained explosions, millions of years of fusion happening every second, hydrogen turning into helium in the core and releasing the energy that warms your face and grows the food you eat and powers nearly every cycle on Earth. The sun is enormous. It contains more than 99% of all the mass in the solar system. Everything else, every planet, every moon, every asteroid, every comet, is less than 1% of what the sun is. If you removed the sun and replaced it with a scale, you would need to pile all the planets on one side and find something roughly 100 times the mass of Jupiter to balance the other. And yet, for all that, the sun is not an especially large star. It is average, medium, in the middle of the range for stars in the galaxy. There are stars out there so large that if you place them where the sun is, they would extend beyond the orbit of Jupiter. The sun, in the context of the galaxy, is modest. But here, in this particular corner of space, it is everything. The source of nearly all the energy in this small system. The reason this planet is warm, the reason water is liquid, the reason anything grows. And it has been burning quietly and steadily for about 4.5 billion years, without interruption, without dimming, without a single day off. There is a moon of Mars that does something no other moon in the solar system does. Phobos, the larger of Mars's two small moons, though larger here is a relative term, since Phobos is tiny enough to fit within many cities' orbits so close to Mars and moves so quickly that it outpaces the planet's own rotation. Mars spins slower than Phobos orbits. The result is that from the surface of Mars, Phobos rises in the west and sets in the east, moving backwards across the sky, against the direction every other moon in the solar system appears to travel. And it does this twice in a single Martian day. Rise, cross the sky, set, and then, hours later, rise again from the same wrong horizon. A moon lapping its own planet, moving faster than the world beneath it. Phobos is also slowly spiraling inward toward Mars, getting closer with each orbit, by a small amount each year. In somewhere between 30 and 50 million years, it will either crash into the Martian surface or be torn apart by Mars's gravity as it gets too close, scattering into a ring of debris around the planet. Mars will one day have rings, brief ones, geologically speaking, but real. For now, Phobos just zips across the Martian sky twice a day, small and quick and moving the wrong way, doing what it has done for a very long time without anything to observe it. Until recently, when we sent machines to look. There is a particular kind of perspective that changes things permanently once you have it. If you were standing on Mars on a clear night, and Mars does have clear nights, cold and thin-aired and star-filled, and you look toward the inner solar system, you would find Earth. It would appear as a small blue-white point of light, pale, steady, unremarkable at first glance, in the way that all stars at first appear unremarkable. You could cover it with your thumbnail. On that tiny point would be every ocean and every mountain, every city and every forest, every person you have ever known, every piece of music ever written, every painting, every word in every book, every kindness ever extended between people in the long history of people extending kindness, all of it contained in something you could obscure with your thumb from a neighboring planet. This is not meant to make you feel small in a diminishing way. Quite the opposite. What the image reveals is not insignificance, but concentration. Everything that matters, everything complex and alive and meaningful, gathered into one small blue point in the dark. Nowhere else in this solar system has anything like it. Not that we have found. Not that we have confirmed. The smallness is not the point. The presence is the point. The fact that there is a blue dot at all, in the cold and quiet of the solar system, is the astonishing thing. And you are on it, right now, resting on the only blue dot anyone has ever confirmed. Before we understood Venus as the hostile, pressure-crushed furnace it is, before any spacecraft had descended through its clouds, there was a long period in which Venus seemed like it could be almost anything. Beneath those permanent clouds, some scientists imagined tropical forests, others imagined oceans. It was the right distance from the sun for warmth. It was nearly the same size as Earth. It had an atmosphere. For a long time, Venus seemed like the most likely candidate for a neighboring inhabited world. And then we looked more carefully and learned what the clouds were hiding. Venus rotates backwards. The sun, on the rare occasion it is visible through the clouds at all, crosses the sky in the wrong direction, rising in the west, as we noted, setting in the east but so slowly that a single day outlasts a full Venusian year. The planet completes its journey around the sun before it finishes turning once. Scientists still debate how this came to be. The leading idea involves the sun's tidal influence, the way the sun's gravity acts on Venus's thick atmosphere, creating a torque that, over billions of years, could have gradually slowed and reversed the planet's original spin, a patient unmaking of what was. A reversal so slow that nothing alive could have noticed it happening. Venus spins its slow backward day beneath those clouds without interruption, without any surface feature to catch the wind, without a moon to pull at its tides, self-contained, unchanged for eons. There is something in Venus's solitude, its cloudedness, its long, strange day, its beauty from a distance that remains quietly compelling. Even knowing what is beneath the clouds, you still look for it at dusk. There are absences in the universe that tell you just as much as presences do. In 1989, when Voyager 2 flew past Neptune, the only spacecraft ever to have done so, it observed a storm. A vast, dark oval in the planet's deep blue atmosphere, roughly the size of Earth, swirling with winds and cloud formations along its edges. Scientists called it the Great Dark Spot. It appeared stable. It appeared like the kind of feature that, like Jupiter's Great Red Spot, might persist for centuries. A few years later, the Hubble Space Telescope turned toward Neptune to observe it again. The Great Dark Spot was gone, completely. No trace of it remained in the part of the atmosphere where it had been, and elsewhere on the planet, a new dark spot had appeared, different location, different shape, the same general character. Neptune's atmosphere had simply dissolved one storm and begun another. In the years between observations, in the cold and dark and distance, the planet had quietly rearranged itself. We don't fully understand how Neptune's atmospheric dynamics work, how storms form there, how long they typically last, what drives their appearance and disappearance. The planet is so far away and has been visited so briefly that it remains, in many ways, genuinely mysterious. What we know is that it is active, that beneath that smooth, deep blue appearance, something is always shifting. That Neptune tends itself in the dark, changing in ways we can only observe occasionally, forming and dissolving features on its own quiet schedule. The universe does not require our attention to continue its work. If you have ever held a handful of sand on a beach, really held it, felt the weight of it, Watch the individual grains shift through your fingers. You have held something that shares a quality with Saturn's rings. Each grain of sand is separate, individual, following gravity in its own small way as it falls. And Saturn's rings are like that, except instead of sand, the grains are ice and rock, and instead of a handful, there are billions upon billions of them. And instead of falling through your fingers, they are orbiting a planet, each one on its own precise path, held in place by the mathematics of gravity and velocity. The rings are not a solid structure. They are a community of separate objects. Some are tiny specks of dust and ice. Others are the size of houses. A few may be as large as small buildings. All of them circling Saturn at different speeds depending on their distance from the planet. The inner ones moving faster, the outer ones slower. The whole collection spread across a distance wider than the gap between Earth and the Moon. Between those particles, there is mostly space. The rings look dense and solid from a distance, the way a cloud looks solid from the ground. Up close, they would be navigable. You could fly a spacecraft through the plane of the rings and likely not hit anything, though you would probably not want to try. Each particle, on its own quiet orbit, has been doing this for hundreds of millions of years. They do not know they are beautiful. They do not know they are rings. They are just each following their particular path, and the whole, from far enough away, is something that takes your breath. If you want to understand what geological restlessness looks like at its most extreme, you look at Io, Jupiter's innermost large moon, a world roughly the size of our own moon, and the most volcanically active body in the entire solar system, more volcanic than Earth, more volcanic than anywhere we have found or confirmed. Io is caught between Jupiter's immense gravity and the gravitational pulls of the other large moons, Europa, Ganymede, Callisto. These competing forces constantly flex and squeeze Io's interior, like kneading dough, generating heat through friction. That heat has nowhere to go but up. It escapes through volcanoes, hundreds of them, active across the surface simultaneously. The eruptions are not subtle. Some plumes of volcanic material shoot hundreds of kilometers above the surface, arching back down in graceful fans that deposit fresh material across the landscape. The surface of Io is in a constant state of being resurfaced. Older impact craters that would be preserved for billions of years on the Moon are buried under new lava here within decades. The surface you would land on today is meaningfully different from the surface that existed when your grandparents were born. Io is covered in colors, sulfur and sulfur compounds in shades of yellow and orange and white and red, pooled around volcanic vents and spread across plains. It has been described as looking like a pizza, which somehow both captures it perfectly and does it no justice at all. It is a world in constant, restless renewal, always shedding its past, always becoming something slightly new. There are places in the solar system where time seems to have stopped, where the surface of a world looks almost exactly as it did 3 or 4 billion years ago, undisturbed by weather or water or the slow grinding of tectonic plates. Mercury is one of those places. Its craters formed by impacts in the early, violent age of the solar system, when debris was still being flung in every direction, as the planets settled into their orbits, are still there, unchanged, preserved with a clarity that makes them almost archaeological. The same bowl-shaped depressions, the same radiating lines of ejecta, the same central peaks formed when the rock rebounded after impact, like a slow-motion splash frozen in stone. On Earth, erosion would have smoothed them away. Water and wind and ice and the slow movement of continents would have dismantled them over millions of years. On the Moon, they survive, but are gradually softened by micrometeorite impacts and the slow gardening of the lunar surface. On Mercury, with no atmosphere and no water and no tectonic activity, they simply remain. Some of the craters on Mercury are records of events that happened before complex life existed on Earth, before the oceans settled, before the continents arranged themselves into anything recognizable. The impacts that formed them struck a young solar system, and the wounds are still visible, still sharp-edged in the airless silence. There is something deeply settling about that kind of permanence. The idea that some marks, once made, simply stay. That the record of an ancient moment can survive, intact and readable, across an almost incomprehensible span of time. Some things, once shaped, hold their form for longer than we can easily imagine. Hold your hand out flat, palm upward, and look at it for a moment. The skin, the slight rise and fall of breathing, the warmth of it. Now consider what surrounds this planet that makes that hand possible. Earth's atmosphere, the layer of air that you are breathing right now without thinking about it, is extraordinarily thin in the context of the whole planet. If Earth were the size of an apple, the atmosphere would be thinner than the apple's skin, a film, a coating so slight that from space it appears as a faint blue haze at the edges of the planet, barely visible, easily overlooked. And yet it does everything. It filters radiation from the sun, absorbing wavelengths that would otherwise damage living tissue. It distributes heat around the planet, carrying warmth from the equator toward the poles and moderating temperatures everywhere. It holds water vapor and forms clouds that regulate how much sunlight reaches the surface. It carries the oxygen you are breathing. It creates the pressure that keeps your blood from boiling. It slows incoming space rocks, burning most of them to nothing before they reach the ground. All of that from something thinner than apple skin. The atmosphere is not a wall. It is more like a conversation, a continuous exchange between the planet and space, between chemistry and sunlight and gravity, always in motion, always adjusting, always doing its quiet and essential work. You are alive, in large part, because of something you cannot see and rarely think about, something so thin it barely shows up from a distance. Breathing it in right now, as you always have, as you always will. There is a force surrounding this planet that you have never seen and cannot feel, and yet depends on entirely. Earth's magnetic field, generated deep in the planet's interior, in the churning liquid iron of the outer core, a slow, convecting flow of molten metal that creates electric currents, and those currents generate a magnetic field that extends far out into space, forming a protective bubble around the planet called the magnetosphere. The solar wind, a constant stream of charged particles flowing outward from the sun, strikes this bubble continuously, and the magnetosphere deflects it, bends it around the planet, sends it streaming past, harmless, into the outer solar system. Without this deflection, the solar wind would slowly strip away Earth's atmosphere. It would erode it, particle by particle, over millions of years, the way it has stripped Mars's atmosphere, because Mars lost its significant magnetic field long ago, and its air has been thinning ever since, leaving it the cold, thin-aired world it is today. Earth's magnetic field makes the air possible, makes the water staying in oceans possible, makes the whole accumulated complexity of life on this planet possible, quietly and invisibly, from somewhere deep in the molten dark below your feet. The evidence of it appears occasionally at the poles, where charged particles following the magnetic field lines into the atmosphere create light, the auroras. Green and violet and pale gold curtains of glow, visible on dark nights in high latitudes. Something vast and invisible, protecting everything, announcing itself only in beauty. Light arrives at Neptune as something barely recognizable as sunlight. The sun, from Neptune, appears not as the broad, warm disk we know, but as an intensely bright point, a star among stars, just noticeably larger than the others, but not dramatically so. The warmth it provides is negligible. The light it casts is roughly 900 times dimmer than what reaches Earth. Midday on Neptune. The brightest moment of the day on the most distant planet is dimmer than twilight on Earth. Not deep twilight, not full dark, but the grey, softening light of late evening, the kind where you can still read a page, but probably wouldn't choose to. That faint light falls on a planet of extraordinary blue, a color caused by methane in the atmosphere absorbing red wavelengths and reflecting blue, a deeper, richer blue than Uranus, despite similar composition, for reasons scientists still find slightly puzzling. Neptune seems bluer than it should be. In that dim, blue-lit world, wind moves faster than anywhere else in the solar system. Clouds of frozen methane drift across the atmosphere. Storms form and dissolve. The planet radiates more heat than it receives, something churning in its interior, some leftover warmth from formation, or some process not yet understood, keeps it warmer than physics alone would predict. Neptune is cold and dark and stormy, and faintly lit, and actively mysterious. It is also, from photographs, one of the most quietly beautiful planets in the solar system. That deep, saturated blue, suspended in the dark. Something can be dim and still be lovely. Something can be cold and still be alive with motion. There is a landscape on Mars that existed long before anything on Earth had learned to breathe. The ancient river channels of Mars, long dry valleys carved by flowing water, visible in satellite images as sinuous lines crossing the red landscape, are some of the oldest readable geological features in the solar system. They trace paths that water once took, billions of years ago, when Mars was warmer and wetter, and its atmosphere was thicker. The water is gone now. Some escaped into space as the atmosphere thinned. Some may be frozen underground, locked in permafrost deep beneath the surface. Some may be present in small amounts in the polar ice caps, but the channels remain, carved in stone, the record of a time when Mars was a meaningfully different world. Standing in one of those ancient valleys in imagination, for now you would be standing in the path of something that flowed here before the first fish appeared on Earth, before the first tree, before the first creature that could look up and wonder about the sky above it. Mars has a past. A wet past, a complicated, geological past that we are only beginning to read. And the question it raises is not merely scientific, it is almost philosophical. If Mars was once warm and wet and held liquid water, did it also, in that earlier time, hold something living? Did life begin there, only to fade as the planet cooled and dried? We don't yet know. The question sits quietly in those ancient, dry riverbeds, waiting for something patient enough to come and look closely. Some of the best discoveries in science have arrived sideways, not from looking directly at something, but from noticing that something nearby behaved unexpectedly. The rings of Uranus were found this way. In 1977, astronomers were observing Uranus pass in front of a distant star, a technique used to study the planet's atmosphere, by watching how the starlight changed as the planet moved across it. But something odd happened before the planet itself reached the star. The star's light dimmed, briefly, in a pattern, then recovered. Then the planet passed in front of the star, and the light disappeared completely, as expected. Then the star reappeared on the other side, and then it dimmed again, in the same pattern, mirrored, before finally clearing. Something was orbiting Uranus, something that blocked starlight, something that came in a series of distinct rings. No one had been looking for rings. They were simply there, interrupting an observation designed for something else. 9 rings were identified that night, narrow and dark, nothing like Saturn's broad, bright rings, but real. 11 rings are now confirmed, with additional faint material between them. Uranus had been visited by telescope for nearly 2 centuries before anyone noticed the rings. They had been there all along, dark and narrow, quietly circling a tilted planet, waiting for someone to catch the right starlight dimming at the right moment. Some things reveal themselves only indirectly, only when you are paying attention to something else entirely. There is a machine made by human hands that is now further from Earth than anything we have ever built. Voyager 1, launched in 1977, the same year the rings of Uranus were discovered, has been traveling outward from the solar system for decades. It passed Jupiter, it passed Saturn, It crossed the boundary where the solar wind gives way to interstellar space. It is now moving through the space between the stars, the first human-made object to have done so. The distance is not easy to hold in the mind. The radio signal from Voyager 1, traveling at the speed of light, takes more than 22 hours to reach Earth. A message sent to it now would arrive more than 22 hours later. A reply would take another 22 hours to return. And yet the signal arrives, faint, barely detectable, requiring the largest radio antennas on Earth to hear but real. A whisper from beyond the solar system, sent by a machine the size of a small car, powered by the slow decay of radioactive material, still transmitting data after all these decades. Voyager 1 carries a golden record, a disk of sounds and images and music from Earth greetings in 55 languages. A piece by Bach, sounds of rain and wind and surf and laughter. Not because anyone expects it to be found soon, or perhaps ever, but because the people who made it felt that something traveling that far into the dark should carry something of us. Something of us is out there right now, moving quietly between the stars, carrying the sounds of rain. On a moon of Saturn so small it almost seems like a mistake. A world you could drive across in an afternoon. Something extraordinary is happening beneath the ice. Enceladus, barely 500 kilometers across, smooth and white and almost perfectly reflective, one of the brightest objects in the solar system. And from its south pole, in long graceful arcs that shoot hundreds of kilometers into space, geysers of water vapor and ice particles are continuously erupting. Not occasionally, continuously. The plumes are always there, always rising, always releasing water from the ocean beneath the ice into the space above. Some of that water falls back to the surface as snow. Some of it escapes entirely, forming one of Saturn's rings, the E-ring, the broad, faint outer ring that Enceladus feeds with its constant eruptions. The ocean beneath the ice of Enceladus is warm, heated by tidal flexing, the same mechanism that heats Io's interior but gentler here. And where there is warm water and the kinds of organic molecules that have been detected in those plumes, there is at least in principle the possibility of something living. A spacecraft has flown through those plumes and tasted them, found water, found salts, found organic compounds, found molecular hydrogen, which on Earth is produced in hydrothermal vents on the ocean floor, places teeming with life. Enceladus is shooting potential habitability into space, offering it freely to whoever happens to be passing by. There is a quality to Jupiter's magnetic field that makes every other planet's magnetic field seem modest. Jupiter's magnetosphere, the region of space dominated by its magnetic influence, is the largest structure in the solar system. If you could see it with the naked eye from Earth, it would appear larger than the full moon. Despite Jupiter being hundreds of millions of kilometers away, it extends millions of kilometers toward the Sun and stretches into an enormous tail that reaches almost to Saturn's orbit on the far side. Jupiter's magnetic field is roughly 20,000 times stronger than Earth's. A compass needle, if one could exist and function in Jupiter's vicinity, would be dragged and spun by forces that bear no resemblance to the gentle orientation our compasses experience here. The field is generated by something Jupiter has that Earth does not, a layer of metallic hydrogen in its deep interior. Under the crushing pressure of Jupiter's interior, hydrogen, normally an insulating gas, is compressed into a state where it conducts electricity like a metal. This conducting layer, rotating with the planet, generates electric currents, and those currents generate the enormous magnetic field that wraps around everything. The auroras this produces at Jupiter's poles are permanent, not occasional light shows triggered by solar events, as Earth's auroras are, but constant glowing rings around both poles, always present, always burning with energy, larger than Earth, continuously alight, a planet with permanent auroras, glowing at both poles, always. The universe is not always subtle about its grandeur. Sometimes it simply leaves the light on. Everything that has ever been built, every city that has ever risen, every civilization that has ever organized itself and left a record, every poem and prayer and promise, all of it has happened in one particular kind of pressure. The pressure of Earth's atmosphere at sea level, about 101,000 pascals, if you want the number. The weight of a column of air extending from where you are to the edge of space, pressing down on every surface with a force so familiar and constant that you have never once noticed it. Now consider Venus. The atmospheric pressure at the surface of Venus is about 90 times greater. If you were standing on the Venusian surface, which no human has, and likely will not for a very long time, the air pressing against you would feel like being 900 meters underwater. The kind of depth where submarines are built to withstand the crush. The kind of depth where pressure itself becomes a physical presence, something you feel rather than merely inhabit. The spacecraft that descended to Venus's surface were designed to survive this pressure, along with the extreme heat. They survived for a short time, the longest. A Soviet probe lasted just over 2 hours before the environment overwhelmed it. 2 hours on Venus. Enough time to take some measurements, send some data, and then be quietly undone by a planet that is, in every physical sense, deeply inhospitable. And yet, Venus is beautiful from here. Peaceful looking, the second brightest thing in our sky after the moon, glowing with reflected light, serene and silent in the evening. Distance softens many things. The view from far away is rarely the whole story. There is a quality to Earth that becomes more striking the more solar system you learn. More than 2/3 of this planet's surface is covered in water. Not ice, not vapor liquid water, sitting openly on the surface, in oceans that average several kilometers in depth and have been liquid for most of the planet's history. Waves move across them, currents circulate through them. Light penetrates their upper layers and fades to absolute darkness below. No other planet we have confirmed has this. Mars had water once, but lost it. Venus may have had oceans in its early history, before the runaway greenhouse effect transformed it. The outer moons have water, but locked beneath ice, or mixed with other compounds. Earth alone has open, sunlit, breathing ocean sitting on its surface right now, today, as you rest. The oceans regulate the planet's temperature. They absorb enormous amounts of heat and release it slowly, smoothing out the extremes that would otherwise make large portions of the land uninhabitable. They drive weather, they carry nutrients, they hold the majority of life on Earth, not the forests and the fields, but the ocean, which remains largely unexplored, largely unmapped in detail, full of creatures and ecosystems and chemical processes we are still learning to understand. The deepest point in Earth's ocean is deeper than the tallest mountain is tall. We have sent humans to the moon, but the number of people who have descended to the deepest point of the ocean can be counted on one hand. The most alien place you could visit might not be another planet. It might be the deep water of this one. Dark, cold, pressurized, ancient, and still largely unknown. Right here, beneath the surface of the world you already live on, at the very edge of the solar system, so far from the sun that it appears as little more than a bright star in the sky. A small world made of ice and rock and nitrogen frost carries a feature on its surface that stopped scientists mid-sentence when they first saw it. Pluto's mountains stand as tall as the Rocky Mountains on Earth. Real mountains, not small ridges or gentle rises, but significant, jagged peaks of water ice, standing in an atmosphere so thin it barely qualifies as one. Under a sky so dark the stars are always visible. Water ice, at the temperatures of Pluto's surface, behaves like rock. It is rigid and strong and capable of maintaining the structural integrity required to build a mountain. The mountains of Pluto are not metaphorical or approximate. They are mountains in the fullest sense, formed by some geological process that scientists are still working to understand, since Pluto was long thought to be geologically dead. It is not. The heart-shaped nitrogen ice plain pulses with slow convection. The mountains stand. Something, possibly internal heat from the decay of radioactive elements, is keeping Pluto subtly active, subtly alive in the geological sense, and it is cold there in a way that requires patience to understand. Cold enough for nitrogen to freeze. Cold enough that the atmosphere itself thin as it is partially collapses and settles as frost on the ground during the long winter of Pluto's 248-year orbit, then slowly sublimates back into gas as Pluto draws closer to the Sun. Mountains made of frozen water on a world where the air freezes solid in winter, and yet something inside it, ancient and quiet, still generates just enough warmth to keep it moving. Long before there were planets, long before there was a sun, there was a cloud. A vast, diffuse cloud of gas and dust drifting in one corner of the Milky Way. Mostly hydrogen and helium, with traces of heavier elements forged in earlier stars that had lived and died before our solar system existed. The cloud drifted quietly for perhaps hundreds of millions of years, slowly, without purpose or direction, simply present in the way that gas clouds are present thinly, coldly, across enormous distances. Then something disturbed it. Perhaps a nearby supernova, a dying star's final explosion sent a pressure wave through the cloud, causing parts of it to compress slightly. And in those compressed regions, gravity took hold. Gas fell toward gas. Pressure increased. Temperature rose. The cloud began to collapse toward its own center, slowly at first, then faster, the way any falling thing accelerates. At the center, the material grew dense enough and hot enough to ignite nuclear fusion. The Sun was born. Around it, the remaining gas and dust flattened into a spinning disk, the same disk from which all the planets eventually formed. Dust grains stuck together into pebbles. Pebbles collided and merged into rocks. Rocks accumulated into planetesimals. Planetesimals gathered into planets. Over millions of years, the solar system assembled itself from the remains of that ancient cloud. Everything here, the sun, the planets, the moon, the oceans, the mountains, every molecule in your body, was once part of the same quiet, cold, drifting cloud. We all came from the same place, the same stillness, the same slow gathering toward something. There is a kind of kinship between Earth and Mars that is easy to miss, because the differences are so immediately apparent. Mars is cold and thin-aired and red. Earth is warm and blue and alive. They seem as different as two places could be. And yet, Mars's axis is tilted at about 25 degrees. Earth's is tilted at about 23.5. Close enough that Mars experiences seasons in the same fundamental way we do a northern summer when the North Pole tilts toward the sun, a southern winter when it tilts away. The seasons are longer on Mars because a Martian year is nearly twice an Earth year, and they are more extreme because Mars's orbit is more elliptical, bringing it noticeably closer to the sun in southern summer and farther in northern summer. But the basic rhythm is the same: spring, summer, autumn, winter, turning in their annual order, shaping the planet's weather and the behavior of its ice caps, which expand in winter and retreat in summer just as Earth's do. When the Martian North Pole tilts toward the sun in summer, the carbon dioxide frost that has accumulated over winter sublimates back into the thin atmosphere. The polar cap shrinks. Dust storms can brew. The whole planet, in its thin-aired way, responds to the season. And at the same time, somewhere on Earth, it is also changing season. The two planets, different in almost every meaningful way, are tilted at nearly the same angle, nodding toward and away from the same sun, keeping something like the same slow planetary time. The kinship is small, but it is real. On a planet known for its storms and its size, something exists at the North Pole that has no equivalent anywhere else in the solar system. Saturn's North Pole has a hexagonal storm, a six-sided weather pattern persistent for decades, each side of the hexagon longer than the diameter of Earth. A geometric storm, a hurricane with corners. It sounds like something invented, a detail too precise and strange to be natural. And yet there it is, confirmed by multiple spacecraft, observed over many years, stable in its extraordinary shape. The hexagon forms because of the way Saturn's atmosphere flows. A fast-moving jet stream at that latitude creates a standing wave pattern, and the mathematics of fluid dynamics at that speed and that rotation rate produces reliably, repeatedly 6 sides. Not 5, not 7, 6. The same phenomenon can be reproduced in laboratory experiments with rotating fluids. It is not random. It is what the physics of the situation produces, as naturally and inevitably as water flowing downhill. And yet, knowing the mechanism does not entirely dissolve the wonder. There is still something quietly astonishing about the fact that physics, impersonal, mathematical, indifferent, produces hexagons on planets. That the same geometry found in snowflakes and honeycombs appears at the pole of a gas giant, maintained by fluid dynamics across a span wider than continents. The universe does not intend these shapes. It simply follows its own rules, and the rules, sometimes, produce something that looks almost deliberate. Something that looks, from a distance, almost like a choice. There is a planet in the outer solar system that is cold in a way that sets it apart from all the others, not because of its distance from the Sun, though that is considerable, but because of something much stranger. Uranus is cold because it keeps its heat to itself. Every other planet in the solar system radiates more energy than it receives from the Sun. Jupiter glows with internal warmth. Neptune generates heat from some still debated internal source. Even Earth releases geothermal heat. These planets are not just warmed by sunlight, they are warming themselves from within, bleeding leftover heat from their formation into space. Uranus does not, or almost does not. The heat that should be there, the residual warmth from the planet's formation, the heat that all planets are born with, is somehow trapped, somehow sealed inside, not reaching the surface, not radiating outward in the way it should. No one knows exactly why. The most common suggestion involves the way Uranus is layered internally, that something about the structure of its interior creates a barrier, a kind of thermal lid that prevents the deep heat from rising to the upper atmosphere where it could escape. The result is a planet colder at the cloud tops than Neptune, despite being significantly closer to the Sun. A planet that runs almost entirely on sunlight, pale, distant sunlight, rather than the internal warmth that sustains the others. Uranus holds something in, something ancient and warm, sealed inside, not given away. There is a particular kind of restraint in that, something kept close, for reasons the universe has not entirely explained. If you were to stand somewhere in the outer solar system and look back toward the Sun, really look, without atmosphere to scatter the light or planet to stand on, just floating in the dark, you would see something that rearranges your sense of where things are. The planets, all 8 of them, orbit in roughly the same flat plane. From above or below, the solar system looks like a disk, a thin, flat arrangement, everything circling in the same direction, everything staying close to the same plane, as if painted on a single vast surface. This is not a coincidence. It is a consequence of how the solar system formed. When the original cloud collapsed and began to spin, conservation of angular momentum, the same physics that makes a spinning ice skater pull in their arms and speed up, flattened the cloud into a disk. Material in the disk stayed in the disk. The planets formed in the disk. They have been orbiting in the disk ever since. From the side, the solar system is almost nothing, a thin line of light and motion, barely visible against the dark. From above, it is a slow wheel, a flat arrangement of worlds all going the same direction, all staying close to the plane their formation dictated. The orderliness of it is striking. 8 planets, diverse in almost every way, sharing the same fundamental orientation, keeping, across billions of years, the shape of the cloud they came from, the memory of their origin, written in the geometry of their orbits. Even in the present, the past leaves its shape, There is a moon in the outer solar system that travels the wrong way. Triton, Neptune's largest moon, orbits Neptune in the opposite direction to Neptune's rotation. Every other large moon in the solar system orbits in the same direction as its planets spin, because moons, like planets, generally form from the same spinning disk of material that formed the planet itself and inherit its direction of rotation. Triton did not form this way. Triton was captured. Long ago, it was a separate body, likely a large object from the Kuiper belt, the region of icy bodies beyond Neptune's orbit that wandered too close to Neptune and was caught by its gravity. The capture would have been a violent, dramatic event, a close encounter that transformed a free traveling body into a moon, settling it into the backwards orbit it has followed ever since. The capture changed both parties. Triton's orbit is slowly decaying, moving closer to Neptune, with each passing year, drawn inward by tidal forces. In perhaps 3.6 billion years, it will come close enough to be torn apart by Neptune's gravity, scattering into a ring system around the planet. Neptune will eventually have rings, temporary, geological speaking, but real, made from what was once a captured traveler. Triton is also geologically active. Nitrogen geysers erupt from its south pole, driven by sunlight warming the thin ice and causing nitrogen to sublimate and escape in dark plumes that streak the surface. A captured moon, traveling backwards, slowly falling, erupting dark plumes into the cold. Everything in the solar system is always in the process of becoming something else. The asteroid belt, that region between Mars and Jupiter that appears in films as a dense, nearly impassable field of tumbling rocks, is, in reality, one of the quieter and emptier places in the solar system. If you were to fly through it, you would probably see nothing. The asteroids are real. There are millions of them, but the space they occupy is so vast that they are spread extraordinarily thin. The average distance between asteroids in the belt is roughly 1 million kilometers. Not meters, not kilometers. 1 million kilometers. If you stood on one asteroid, the nearest other asteroid would likely be invisible to the naked eye, too distant to resolve as anything more than a point of light. The spacecraft we have sent through the asteroid belt did not need to dodge or weave or navigate carefully. They flew straight through and encountered nothing, statistically consistent with the emptiness. The combined mass of everything in the asteroid belt, all the millions of asteroids, added together, is less than 4% of the mass of the Moon. It is not a failed planet, as was once thought. It is simply a region where Jupiter's gravitational influence prevented material from gathering into a planet, leaving it scattered and thin and quiet. A belt in name. In reality, something closer to an enormous, sparsely populated silence. A region where rocks drift slowly in their individual orbits, each one an island, rarely coming within sight of another, moving through their quiet portion of the solar system without urgency or direction or company. Beneath your feet right now, the ground feels solid, permanent, fixed, the foundation of everything. It is moving. Earth's continents drift across the surface of the planet on tectonic plates, enormous slabs of crust floating on the partially molten rock of the mantle beneath them. The motion is slow, about the rate of fingernail growth, a few centimeters per year, depending on the plate. In a human lifetime, the continents move roughly the distance of a tall person's height, but over geological time, this adds up to everything. The Atlantic Ocean has opened. The Himalayas have risen. India has collided with Asia. Antarctica has moved from the tropics to the pole. Every piece of land you have ever stood on was, at some point in the past, somewhere else, and will be somewhere else again, long after any of this matters to any of us. This process, plate tectonics, is something Earth has, and most other planets in the solar system do not. Mars has no significant plate motion. Venus may have had it once, but appears largely locked now. The Moon is geologically still. Earth alone, among the rocky inner planets, continues to recycle its crust, pulling old rock into the mantle and pushing new rock up at ridges and volcanoes, renewing itself constantly. The ground beneath you is not fixed. It is borrowed. It has been somewhere else and will go somewhere else, slowly, without asking permission, on a timescale that makes human history feel like a held breath. And right now, it is absolutely still beneath you, holding you, as it always has. Something about the number 50 feels like a threshold, like the halfway point of a long, quiet walk, where you have come far enough that turning back would be no shorter than continuing forward. So, we continue, gently, into the second half of the night. There is a moon in the outer solar system that does not belong. Triton orbits backwards. But Neptune has another distinction, worth sitting with a moon called Nereid, with the most elongated orbit of any moon in the solar system. It swings so far from Neptune, and then so close again, that its distance varies enormously across a single orbit. But it is Triton's backward journey that carries the particular quality of something displaced, something that arrived from elsewhere and stayed. And Neptune itself has a quality of the displaced. It was not always where it is now. In the early solar system, the giant planets were arranged differently closer together, interacting gravitationally in ways that eventually pushed Neptune outward to its current distant orbit. Neptune migrated. It moved. The whole outer solar system was reshuffled in a period called the Late Heavy Bombardment, when this migration sent debris cascading inward and outward, scarring the inner planets with craters and scattering the Kuiper belt into its current shape. Neptune arrived at its present position. It was not born there. It traveled, slowly, over millions of years, pushed by the combined gravitational influence of Jupiter and Saturn and Uranus, until it settled into the orbit it now follows. Everything in the solar system is where it is because of a history of movement. Nothing simply appeared where it currently resides. The planets found their places. They arrived at their orbits through a long, dynamic, sometimes violent process of negotiation with gravity. Even the most distant, the most still-seeming things traveled to get where they are. There is a place in the solar system where the ground is continuously being renewed, where what existed yesterday is buried under what arrived today, where the surface is in a state of such constant change that no feature on it lasts long enough to be considered permanent. We mentioned Io briefly before, but the volcanic activity there deserves to be held quietly for a moment longer. The plumes of Io's volcanoes reach heights that would place them, if transplanted to Earth, well above the cruising altitude of commercial aircraft. The material they eject, sulfur compounds, sulfur dioxide, silicate rock, falls back to the surface in great fan-shaped deposits, painting the landscape in yellows and oranges and whites that shift in color as different sulfur compounds cool at different rates. There are lakes of molten silicate on Io, real lakes, but made of lava, held in calderas, volcanic depressions, and rippling with heat. Some of the hottest surfaces in the solar system outside the sun itself. And through all of this, through the eruptions and the plumes and the constant deposition of new material, Io's shape stays roughly the same. The mass ejected into space is replaced by mass rising from the interior. The surface changes, while the volume remains constant. A planet perpetually molting, perpetually renewing, perpetually burning off its own skin and growing new skin beneath. It is, in a strange way, the most alive-seeming of all the moons. Not because anything lives there, nothing we know of could, but because it behaves the way living things behave. Consuming, renewing, changing, never quite settling into stillness. A world that cannot rest. Hold your breath for just a moment. Not long, just long enough to notice it. The brief pause before the next inhale. The small, contained world of a single held breath. The atmosphere of Venus holds its breath differently. Venus's clouds are not water clouds. They are clouds of sulfuric acid, dense, layered, globe-spanning, permanent. They form in the upper atmosphere where temperatures are cooler, and they circulate around the planet in a pattern that rotates faster than the planet itself rotates. The cloud layer moves at its own pace, divorced from the surface beneath it, sweeping around Venus in just a few Earth days while the planet takes months to rotate once. These clouds are so thick and so complete that they reflect about 70% of the sunlight that reaches them. Most of the sunlight that falls on Venus never reaches the surface at all. It bounces back into space from the top of the cloud layer, making Venus brilliant to us but dim to whatever hypothetically exists beneath. The surface of Venus has never been seen from orbit. No satellite image shows the ground. Every map of Venus's surface was made using radar radio waves sent down through the clouds, bouncing off the surface and returning. The return signal interpreted by computers into topographic maps. We know the shape of Venus's landscape through the echoes of radio waves, not through any image. The ground of Venus is hidden, permanently, behind clouds of acid that have never parted, not once in recorded history, not once since Venus became the planet it is. What is down there, in the dim, acid-filtered light, on the hot rock beneath the cloud floor, has never been properly seen. There is a particular quality to the way Jupiter dominates its neighborhood. It is not just that Jupiter is large, though it is. Vastly it is that its gravity reaches outward and organizes things, shapes things, determines, in meaningful ways, what the rest of the inner solar system looks like. Jupiter's gravitational influence is thought to have prevented the asteroid belt from coalescing into a planet. Its repeated gravitational tugs kept the material there stirred and scattered, preventing accumulation. The belt exists in the shape it does because Jupiter is where it is. Jupiter also acts as a kind of gravitational shield for the inner solar system. Its enormous mass attracts comets and asteroids that might otherwise travel inward toward Earth and the other rocky planets. Some of these objects are captured into Jupiter's orbit. Others are flung outward into interstellar space. Others impact Jupiter itself. In 1994, astronomers watched a comet Shoemaker-Levy 9, which had been captured and torn apart by Jupiter's gravity, fall in pieces into Jupiter's atmosphere over several days. The impact sites were larger than Earth. Jupiter absorbed the comet, as it has absorbed countless other objects across its long history. How often Jupiter has deflected something that might otherwise have reached Earth is impossible to calculate precisely. But the presence of a massive planet in the outer solar system, drawing in or redirecting much of the debris that might otherwise wander inward, is thought by many planetary scientists to have made Earth's surface more stable than it might otherwise have been, more survivable, more continuous. Jupiter does not know it is protecting anything. It simply has mass, and mass has consequences. There is a measurement that seems impossible until you sit with it. The pressure at the surface of Venus, 90 times Earth's atmospheric pressure, is not Venus's most extreme quality. That distinction might belong to the temperature, which reaches around 465 degrees Celsius. Not at the peak of the day, not in summer. Always, day and night, equator and pole. In every season, the surface of Venus maintains roughly the same temperature. The atmosphere is so thick, so efficient at trapping and distributing heat, that the temperature barely varies from one part of the planet to another, or from day to night. The difference between the hottest and coldest places on Venus's surface is smaller than the difference between a warm and cool day on Earth. This uniformity is its own kind of extreme. Earth's weather exists because of temperature differences, warm air here, cool air there, the atmosphere flowing between them, creating wind and weather, and the endlessly varied climate that makes life on the surface so different from one place to another. On Venus, the temperature uniformity means something different happens in the atmosphere. Strange, slow circulation patterns, clouds moving in their own divorced rhythm. There is no relief from the heat on Venus, no cool side, no shadow season, no place to wait out the worst of it. Earth's variation, the cool nights, the changing seasons, the difference between a forest and a desert, is not a flaw or an inconvenience. It is the signature of a living, circulating atmosphere doing complicated work. The variation is what makes it home. There are oceans on Earth that have never known sunlight. Below a certain depth, roughly 200 meters, sunlight no longer penetrates. Below 1,000 meters, it is completely dark. The deep ocean, which covers the majority of Earth's surface and holds the majority of Earth's water, exists in permanent darkness, cold, high pressure. Still, in the sense that storms and waves and the churning of the surface never reach it. And yet it is full of life, creatures that have never seen sunlight, creatures that generate their own light through bioluminescence, creating brief cold flashes in the dark. Creatures clustered around hydrothermal vents on the ocean floor, where superheated water emerges from the rock and supports entire ecosystems. Without any energy from the sun, at all ecosystems fueled entirely by chemistry. These vent communities were discovered only in 1977. Before that, no one knew they existed. The idea that life could exist without sunlight, that it could build complex ecosystems in total darkness on chemical energy alone, was not something that had been confirmed. Now we know it, and the knowledge has changed how we think about life elsewhere in the solar system. Europa's dark ocean, Enceladus's warm interior, Titan's chemistry. All of them suddenly seem more plausible as places where something might be quietly alive, not needing the sun, not needing what we assumed was necessary. Even as you rest right now, somewhere in the deep ocean below a sea surface somewhere on Earth, something is moving in the dark, quietly, without light, without asking anything of the sun. Life, finding a way. There is a piece of information about the sun that takes a moment to land properly. The light warming your face, the light that makes days possible, that drives photosynthesis, that powers the water cycle, that makes the sky blue began its journey inside the sun not 8 minutes ago, when it left the sun's surface, but much, much longer ago. Energy generated in the sun's core by nuclear fusion does not travel directly to the surface. It cannot. The interior of the sun is so dense that a photon of light, once generated in the core, is immediately absorbed and re-emitted by the plasma surrounding it, then absorbed and re-emitted again and again, moving outward, but slowly, in a random walk through the dense solar interior, bouncing from particle to particle. The time it takes a photon of energy to travel from the sun's core to its surface, a distance of about 700,000 kilometers, is estimated at somewhere between 10,000 and a million years, depending on the path taken. The sun's interior is so dense that light, the fastest thing there is, takes that long to wade through it. Then, once it reaches the surface, it crosses the distance to Earth in 8 minutes. The warmth on your face right now carries energy that began its journey before the first modern humans existed, before Homo sapiens, before most of what we call human history. It has been making its slow way outward through the sun since then, and arrived here, today, to rest briefly on your skin. Ancient light, finding you, at last, after all that time. Before 1781, no living person had ever seen a new planet added to the night sky. The planets known to ancient astronomers, Mercury, Venus, Mars, Jupiter, Saturn, were the same ones known to every civilization before them, stretching back into prehistory. They moved against the fixed stars. They were tracked and named and integrated into calendars and mythologies and systems of meaning. But the number of them was fixed. Everyone assumed it was fixed. Then, on the evening of the 13th of March, 1781, William Herschel, a musician by trade, an astronomer by obsession, was conducting a systematic survey of the sky from his garden in Bath, England, and noticed something that didn't look quite right. A small disk, rather than the point of light that stars produce. He thought it might be a comet. It was Uranus, the 7th planet. the first planet discovered in recorded history. The solar system grew that night. Not physically, Uranus had always been there, following its 84-year orbit in the outer dark, dimly visible to the naked eye, on a clear night, if you knew where to look and what to look for. But the human solar system grew. The map of what we knew expanded, irrevocably, to include a world that had been present and unrecognized for as long as humans had been looking up. There is something in that moment, the realization that something vast and real had been there all along, simply beyond the frame of what anyone had thought to look for, that resonates quietly. Sometimes, the world is larger than you realized, not because it grew, because you looked more carefully. There is a number that is worth trying to hold. Not to feel small, that is not the point, but to feel the particular quality of wonder that comes from understanding that you are part of something whose scale is almost beyond the reach of words. Neptune has been observed by human astronomers for about 175 years. In that time, it has completed less than 2 full orbits of the Sun. One orbit takes 165 years. So in the entire history of human observation of Neptune, in all the time since Leverrier's letter and the Berlin telescope and the first confirmed sighting, Neptune has not yet gone around the Sun twice. It was discovered partway through an orbit. It completed that orbit. It began another. It is still in the middle of that second orbit now. The solar system operates on timescales that dwarf human history in the most literal way. Neptune has been doing what it does, following its slow, cold, blue arc around the Sun for 4.5 billion years. Human civilization, in that context, is a brief flicker. The time since Neptune's discovery is a barely perceptible fraction of one of its years. And yet, we found it, calculated it into existence with mathematics, watched it complete one orbit in the span of recorded history, named it, sent a spacecraft past it. We are brief, and we are curious, and our brevity does not diminish what we have managed to notice. If anything, it makes the noticing more remarkable. Small, and paying such careful attention. There is a quality to standing at the edge of something that cannot be rushed. On Mars, in the Valles Marineris, a canyon system so vast that the word canyon barely contains it, you would stand at a rim and look across a distance that would, on Earth, stretch from New York to Los Angeles. The canyon drops in places to depths of 7 kilometers. It runs along the Martian equator for roughly the length of the continental United States. It did not form the way Earth's Grand Canyon formed. There was no river carving patiently through layers of rock over millions of years. The Valles Marineris formed largely through tectonic stretching, the Martian crust pulling apart, as the enormous volcanic region, called the Tharsis Bulge, formed and warped the planet's surface. The canyon is, in a sense, a crack in a planet, a place where the ground simply separated and dropped. And it has been there for billions of years, dry and cold, and still, with no wind strong enough to erode it significantly, in Mars's thin atmosphere, with no water to fill or reshape it. If you stood at the rim on a clear Martian day, the opposite wall would be below your horizon. You would not be able to see across. The canyon is wider than the curvature of Mars allows you to see in a single glance. Some things are too large to take in all at once. You can only stand at the edge, look into what you can see, and accept that the rest exists beyond your view. That is not a limitation. That is simply what it means to be a finite person in a very large place. And there is, in that acceptance, something surprisingly restful. There is a particular kind of beauty that belongs to the moment something is seen for the first time. Not discovered, seen. The difference between knowing something exists and actually holding its image, actually receiving its light. When the New Horizons spacecraft flew past Pluto in 2015, it sent back the first clear images of that world, a world known only as a point of light for the 85 years since its discovery. Scientists gathered in a room and watched the images arrive, pixel by pixel, resolved slowly from noise into landscape. Mountains, ice plains, a heart. Some of them wept, not because the data was unexpected, though much of it was, but because something that had existed only as a number, only as a calculated position in a catalogue, only as a faint smudge on photographic plates, had suddenly become a place, a real place, with texture and color and geography, a world that had been quietly existing, undisturbed and unseeable, for 4.5 billion years, now finally visible. This is what telescopes and spacecraft do at their best. They do not merely collect data, they transform abstractions into places. They take what was theoretical and make it present. You do something similar, sometimes, when you sit quietly enough. When the abstract, the day's worries, the future's uncertainties resolves into something more immediate. The feeling of your breath, the weight of your body, the simple fact of being here, present, in a moment that is real and specific and yours. The universe becomes most real when you pay the gentlest, most patient attention to it. And so, sometimes, do you. There is a moon in the outer solar system whose name carries literature into the dark, and whose surface carries something that makes it unlike any other moon we have seen. Titan, Saturn's largest moon, the only moon in the solar system with a thick, complex atmosphere, and not a thin one, but an atmosphere denser than Earth's at the surface, composed primarily of nitrogen, with a rich mixture of organic molecules built up over billions of years of chemistry driven by sunlight acting on methane. Titan's sky is orange, not the orange of sunset, a permanent, deep amber haze that blocks direct sunlight and filters everything into a warm, diffuse glow. If you stood on Titan's surface, you would not see the sun as a disk. You would see only a slightly brighter patch in the orange sky, diffuse and directionless, like light coming through frosted glass. And the landscape beneath that sky is extraordinary. Plains of water, ice, mountains of ice, rivers and lakes and seas of liquid methane, dark and still and cold, reflecting the orange sky in their surfaces. Dunes of organic particles, dark as coffee grounds, sculpted by winds into long parallel ridges. It is, in the most genuine sense, an alien world, and yet it has rain, it has rivers, it has lakes with shores. The processes are familiar: evaporation, condensation, flow, collection, but the substance is different. The familiar made entirely foreign by a change of chemistry. Titan is what Earth might look like if you replaced every molecule of water with methane and turned the temperature down by 180 degrees. The bones of the same story, written in a different language. There is a number that sounds small and implies something vast. The gravity on Mars is about 38% of Earth's, a little more than a third. If you weigh 70 kilograms on Earth, you would weigh about 26 kilograms on Mars. You would be lighter than you have ever felt, lighter than you might have thought it was possible to feel and still be standing on solid ground. Walking would be different. Each step would carry you slightly higher and slightly longer than you expected. Running would feel like bounding. Jumping would feel like something close to flight, a slow rise, a moment of genuine suspension, a gentle return. Objects would fall more slowly. Pour water, and it would arc through the air differently, taking longer to reach the ground. Throw something, and it would travel farther before landing. Everything familiar would be slightly, consistently wrong, not alarmingly, not dangerously, just subtly off in a way that would take constant, gentle adjustment. And the sky above you, as you walked with those long, slow steps, would be pink. Not the dramatic pink of an Earth sunset, but a constant, dusty pink, the daytime color of a world whose atmosphere is thin enough to see through, but thick enough with fine iron oxide particles to tint everything. Pink sky, light body, long, slow steps on rust-red ground. There is something almost dreamlike about the description. Something that belongs to that particular quality of movement that dreams have, where your legs carry you further than they should, where the ground gives more than expected, where gravity is, for once, less insistent than usual. Perhaps that is why Mars, of all the planets, feels closest to somewhere you might have been in sleep. There is a kind of storm that has been running so long it has outlasted empires. Jupiter's Great Red Spot, that vast, centuries-old anticyclone in the southern hemisphere, is the most famous storm in the solar system. But Jupiter's atmosphere contains others, smaller, faster, more transient, white ovals that merge and disappear, brown barges drifting along the equatorial belt, dark features that appear and fade over years. The bands that give Jupiter its striped appearance, alternating zones of lighter and darker cloud, are themselves rivers of wind, flowing in opposite directions in adjacent bands, the boundaries between them turbulent with smaller storms and eddies. The whole visible surface of Jupiter is weather. There is no land beneath it. There is no surface to interrupt it. It goes all the way down. The clouds are made of ammonia and water and ammonium hydrosulfide, arranged in layers at different altitudes, each layer a different temperature and a different color. The pale zones are where gas is rising. The darker belts are where it is sinking. The whole system is a vast, continuous convection, driven by heat rising from below and shaped by the planet's rapid rotation into those characteristic bands. Jupiter's day lasts fewer than 10 hours. For a planet 11 times the width of Earth, that rotation is fast enough to flatten the planet slightly at the poles and bulge it at the equator, the same effect you see in a spinning ball of dough. A planet of weather, spinning fast, striped by its own winds, decorated by ancient storms, doing all of this quietly in the outer solar system, going about its enormous business without pause. There are clouds on Saturn's moon that glow, in a certain quality of reflected light, with something that resembles the color of old gold. Titan's atmosphere contains a particular kind of haze, tholin it is called, named after the Greek word for mud, a complex organic material formed when sunlight breaks apart methane and nitrogen molecules in the upper atmosphere, and the resulting fragments recombine into larger, more complex molecules. These tholin particles are what makes Titan's sky orange. They drift slowly downward through the atmosphere, settling eventually on the surface, coating everything in a thin, reddish-brown film. Tholin is interesting to scientists for a specific reason. When tholin is mixed with water which Titan's surface doesn't have, but which might have been present briefly in the aftermath of meteor impacts, it produces amino acids, the basic building blocks of proteins, the molecular foundations of life as we know it. Titan may be manufacturing, continuously and passively, the raw materials for life. Not life itself. The temperatures are far too cold for the chemistry of life to operate at the surface. But the ingredients, the precursors, the things that, in warmer conditions with liquid water, begin to assemble themselves into something self-replicating. Titan is, in a sense, a laboratory, a slow, cold, amber-lit laboratory, where chemistry has been running uninterrupted for 4 billion years. What it has produced, we have only begun to sample. The universe has a great deal of patience for long experiments. There is a place on Mercury where the sun never shines. Near the poles of Mercury, where the planet's slight axial tilt keeps certain areas permanently in shadow, there are craters wide, ancient impact craters, whose floors have never once been touched by direct sunlight, not in the billions of years since they formed. In those permanently shadowed regions, temperatures are extraordinarily cold, colder than the surface of Pluto on some days, preserved by the total absence of the solar warmth that everywhere else on Mercury is so overwhelming. And in those frozen, lightless craters, there is water ice. Water ice, on the planet closest to the Sun, preserved in shadow, accumulated over billions of years from comets and asteroids, that delivered it to Mercury's surface. Where sunlight reaches, the ice would vaporize instantly. But in the shadow of those ancient craters, it simply stays, frozen, undisturbed, waiting in the dark. The discovery of water ice on Mercury felt, when it was confirmed, like a reminder about the nature of finding things, that presence and visibility are not the same, that something can exist in a place fully and completely while remaining entirely hidden from any angle of light that passes by. There are things in your own life like that, perhaps, things present but not yet illuminated, not yet caught by the right angle of attention, not yet visible, but real. Water, hiding in the shadow of a crater on the sun's closest neighbor, patient and cold and quietly there. There is a quality to Earth's sky that is so constant, so present from the first moment of waking to the last moment before sleep, that it has become invisible through familiarity. The blue. Earth's sky is blue because of a process called Rayleigh scattering sunlight entering the atmosphere encounters molecules of nitrogen and oxygen, and the shorter wavelengths of light, the blues and violets, are scattered in all directions far more than the longer wavelengths. The sky appears blue because blue light is scattered throughout the atmosphere, reaching your eyes from every direction. At sunset and sunrise, when sunlight travels through a greater thickness of atmosphere to reach you, most of the blue has already scattered away, leaving the reds and oranges and golds to arrive directly, painting the horizon. The blue sky is not something that exists in space. In orbit, the sky is black, even in full sunlight. The blue exists only within the atmosphere, only where there is air to scatter the light. It is an atmospheric phenomenon, a consequence of having air, of having nitrogen and oxygen at the right density to interact with sunlight in exactly this way. Mars's sky is pink because of iron oxide dust. Venus's sky is yellow-orange because of sulfuric acid clouds. Our sky is blue because of the particular gases in the particular concentration of our particular atmosphere. Change any of it, and the color changes. The blue sky above you, familiar as breathing, present as gravity, is not the default color of the universe. It is the color of here, the color of this specific world, doing something no other planet we have visited does. Blue is the color of this being Earth. And Earth being Earth is, of all the things in the solar system, the one worth resting inside most fully tonight. There is a force so consistent, so present in every moment of your life, that it is almost impossible to notice as remarkable. Earth's magnetic field, that invisible structure generated in the liquid iron of the outer core, extending far into space, deflecting the solar wind, also does something more immediately personal. It makes navigation possible. It orients migratory birds across continents. It guides sea turtles back to the beaches where they hatched. It allows the salmon to find the river they were born in, years after leaving it. Something in the biology of these creatures reads the magnetic field the way you read a road, sign a direction, a certainty, a sense of where. And through human history, long before GPS, long before satellites, compasses worked because of this field. Sailors crossed oceans by watching a magnetized needle align itself with a field generated 3,000 kilometers beneath their feet. The needle pointed the way home because the planet itself, deep in its molten interior, was generating a signal strong enough to reach the surface and orient a small piece of metal. The magnetic field is not static. It drifts slowly over geological time. The magnetic North Pole is not in the same place it was. A century ago, it has moved hundreds of kilometers, and over deep time, the field reverses entirely, north becoming south and south becoming north, in a process that takes thousands of years and has happened hundreds of times in Earth's history. During a reversal, the field weakens. The protection it provides diminishes. Life has survived these reversals many times. The planet tends itself, rearranges, recovers, continues generating its quiet, invisible, orienting signal from the dark below. There is a moon of Saturn that has inspired more planetary science proposals than almost any other body in the solar system outside of Mars. Enceladus, yes, with its plumes and its ocean, but also the question of what it means, philosophically, for the search for life. Before Enceladus, the search for life in the solar system was largely organized around liquid water, which was thought to require proximity to the Sun. The habitable zone, that region around a star where liquid water could exist on a surface, was the primary framework. Life required sunlight. Life required warmth from a star. Enceladus changed that. Here was a moon of Saturn, far beyond any traditional definition of the habitable zone, with a liquid water ocean, with organic chemistry, with hydrothermal activity, all of it powered not by the sun, but by tidal flexing, by gravity. If life can exist there, and we do not yet know if it does, then the habitable zone is not the right frame. The question becomes not how far a planet is from its star, but whether it has liquid water and chemical energy. And those conditions, it turns out, might exist in many more places than proximity to a star would suggest. The solar system may have multiple habitable environments: Europa, Enceladus, possibly Titan, in a different biochemical sense, possibly others not yet identified. The universe, as always, turns out to be more generous with its conditions for complexity than our initial assumptions allowed. Enceladus did not ask to challenge our assumptions. It simply kept erupting its plumes into space, patiently, for billions of years, until we happened to send something close enough to notice. There is a storm system on Saturn that exists at a scale which makes the concept of weather feel like it needs a new word. The hexagonal storm at Saturn's North Pole has been observed continuously since the Voyager missions in the 1980s. In that time, more than 4 decades of observation, it has not changed shape. The 6 sides remain. The central vortex, rotating within the hexagon, persists. The whole structure maintains its geometry, as though following a template that Saturn has no intention of departing from. Inside the hexagon, winds blow at speeds that would be classified as hypercanes on Earth. Storm systems so powerful they exist only in theoretical models, wind speeds far beyond any hurricane ever recorded. And yet the hexagon itself is orderly. Its edges are defined. It is weather behaving with geometric precision. The color of the interior has changed over time, shifting from blue to gold as Saturn moved from winter to spring in its northern hemisphere, the change in sunlight altering the chemistry of the upper atmosphere and producing different colored compounds. A seasonal color change inside a geometric storm on a gas giant in the outer solar system. Saturn's North Pole is one of the most structured, most organized, most unexpectedly orderly places in the solar system. A planet of gas, a planet of no fixed surface or edge, producing something as precise as a hexagon and maintaining it for decades. The universe makes rules, and then, following only those rules, produces things that look very much like choices, quietly, without asking us what we think. The night is deeper now, not darker, just quieter. The kind of quiet that arrives when the body has fully settled and the mind begins to loosen its grip on the day. This is the hour for the gentler facts, the ones that ask nothing of you except to receive them. There is a moon of Mars that looks nothing like what a moon is supposed to look like. Phobos and Deimos, the 2 small moons of Mars, are not spheres. Gravity rounds things into spheres when they are large enough, when their own mass is sufficient to pull all their material toward a center. Phobos and Deimos are not large enough for that. They are irregular, lumpy, roughly potato-shaped, cratered and pitted, looking less like moons and more like asteroids that wandered too close and were caught. Phobos, the larger of the 2, has a crater on it. Stickney crater, so large relative to Phobos's total size that the impact that created it nearly shattered the moon entirely. Long grooves radiate across Phobos's surface from that crater, cracks or stress fractures, the lasting signature of a collision that came very close to ending this small, irregular world. And Deimos, even smaller, 2 orbits so far from Mars that from the Martian surface it appears as little more than a bright star identifiable as a moon only by its movement against the fixed stars over the course of a night. Not a disk, not a visible shape, just a moving point of light, dimmer than many stars, quietly crossing the Martian sky. 2 small, battered, misshapen moons orbiting a red planet, each one a captured visitor, or a remnant from the early solar system, or something else entirely. Their precise origin is still debated. Every world, no matter how small, has its own unresolved story. There is a moon in the solar system with a sky, not a thin exhalation of gas clinging to a surface, a real sky, thick enough to have weather, thick enough to have clouds, thick enough that if you descended through it, you would feel the pressure increasing the way you feel it in your ears when descending in an airplane. Titan's atmosphere is denser than Earth's. The surface pressure there is about 1.5 times what you feel right now. And the sky, as we have noted, is orange, permanently amber hazy, filtering the dim sunlight into something diffuse and warm-toned that falls evenly on everything below. But here is what gives Titan its particular quality of strange familiarity. Rain falls there. Real rain, not metaphorical, not occasional, but rain in the hydrological cycle sense. Methane evaporates from the lakes and seas. It rises into the atmosphere. It condenses into clouds. It falls again as rain. It flows back to the lakes through rivers and channels that look, in radar images, remarkably like river systems on Earth. The process is identical to Earth's water cycle. The substance is different. The temperatures are different, 180 degrees colder than Earth's coldest places. But the cycling of a liquid through evaporation and condensation and precipitation and flow, that pattern, that rhythm, is something Titan shares with Earth. It rains on Titan right now, as you rest. Cold methane rain, falling through an orange sky onto a frozen landscape, finding its way back to dark, still methane seas. The pattern is familiar, the world is not, and somewhere in that combination is something worth holding gently. There is a characteristic of Earth so fundamental that it is easy to forget it is not universal. Plate tectonics, the slow movement of crustal plates across the surface, driven by convection in the mantle below, the same process that recycles carbon from the atmosphere into the Earth and back again, that builds mountains and opens ocean basins, that drives volcanic activity and earthquake, and the steady renewal of the surface. Earth is the only planet in the solar system definitively confirmed to have active plate tectonics today. And this matters for more than geology. The carbon-silicate cycle, the process by which carbon dioxide is drawn from the atmosphere into rock, carried into the mantle at subduction zones, and returned to the atmosphere through volcanic outgassing acts as a long-term thermostat for Earth's climate. Too much carbon dioxide, and the planet warms. Weathering increases, more carbon is drawn down. Too little and volcanic outgassing gradually restores the balance. This cycle, driven by plate tectonics, may be one of the reasons Earth has remained habitable for billions of years, despite a sun that has gradually brightened over that time. The planet has been regulating its own temperature, not consciously, not in any sense that implies intention, but through the feedback loops of geology and chemistry, maintaining conditions within a range where liquid water persists and life continues. Earth tends itself. It has been tending itself for 4 billion years. Even now, somewhere deep beneath you, the mantle convects. Rock flows, on timescales of millions of years, like an extraordinarily slow and patient fluid. The surface above shifts by centimeters. The planet continues its long, slow, self-regulating work. You are resting on something that is very quietly taking care of itself. There is a quality to the outer solar system that becomes apparent only when you consider how the inner solar system looks from out there. From Uranus, the sun appears as a very bright star, distant, small. The warmth it provides is negligible, about 1/400th of the sunlight Earth receives. The sky, such as Uranus has, is in perpetual dim twilight by Earth standards. And yet, Uranus has clouds, active weather, a magnetic field tilted at an extraordinary angle, almost perpendicular to the planet's rotation, offset from the planet's center in a way that makes it behave unlike any other planetary magnetic field we know. The magnetic field wobbles as Uranus rotates, sweeping through space in a corkscrew pattern rather than a simple dipole alignment. The origin of this strange magnetic field is another of Uranus's unresolved mysteries. It may involve the behavior of water and ammonia in the planet's interior, under conditions of pressure and temperature that create an electrically conducting fluid, not metallic hydrogen as in Jupiter, but something different, something that generates a field in a stranger geometry. Uranus is full of questions. It has been visited only once by Voyager, 2 inches, 1,986, a flyby that lasted a matter of hours, gathering what data it could before moving on toward Neptune. In those few hours, Voyager 2 discovered 10 new moons, 2 new rings, and a magnetic field unlike anything expected. What else Uranus holds in its layered interior, in its tilted, wobbling magnetosphere, in its 27 named moons, remains largely unknown. A planet so full of questions that scientists have been advocating for a dedicated mission there for decades. Patiently, the way the planet itself is patient. There are 2 numbers that, placed beside each other, make the solar system feel like it is breathing. The oldest stars formed when the universe was only a few 100 million years old. The youngest stars are forming right now, in nebulae scattered across the galaxy, as gas clouds collapse and ignite in the same process that formed our Sun 4.6 billion years ago. The solar system sits roughly in the middle of its life. The Sun has burned through about half its hydrogen fuel. It has approximately 5 billion years remaining before it begins to change, expanding into a red giant, consuming the inner planets, ultimately collapsing into a white dwarf. 5 billion years, the same span of time as everything that has already happened, every geological era, every mass extinction, every evolution of every species, every human civilization. That same span lies ahead before any of this draws toward its close. The solar system is, in the broadest sense, middle-aged, not old, not young, settled into its current configuration, stable in its rhythms, with a very long time remaining before anything fundamentally changes. There is something deeply restful in that. The sun will rise tomorrow, and the day after, and the day after that, for a span of time so long that no mind can hold it. The solar system is not ending. It is not in crisis. It is quietly, steadily, doing what it has been doing for billions of years. The planets will keep turning long after tonight, long after all of this. And right now, in this moment, everything is exactly as it has been. Stable, ancient, continuing. There is a place in the solar system so cold that the atmosphere falls out of the sky. Pluto, in the far reaches of its 248-year orbit, moves at varying distances from the Sun. When it is closer, relatively speaking, since Pluto is never truly close, the surface warms slightly. Nitrogen ice on the surface sublimates, becoming gas, rising into the thin atmosphere, giving Pluto a sky, a real, if extraordinarily tenuous sky. As Pluto moves farther from the Sun, the temperature drops again. The nitrogen in the atmosphere, no longer able to remain gaseous, begins to freeze. It condenses and falls not as rain, but as frost, settling back onto the surface as a thin layer of frozen nitrogen. The sky falls. Slowly, quietly, over months and years, the atmosphere of Pluto collapses back into the ground as frost. And then, decades later, as Pluto swings back toward the inner reaches of its orbit, the frost sublimates again, and the sky reassembles itself from what had settled on the ground. A planet that breathes its own atmosphere in and out across its orbital year, inhaling and exhaling on a timescale of decades. Even as you breathe right now, the slow, unconscious rhythm of air, moving in and out, Pluto is doing something that resembles, in its own cold and distant way, the same thing. Drawing in, releasing, on the timescale of a world rather than a body. Everything breathes, everything moves in cycles, everything finds its rhythm, at whatever scale it happens to be. There is something about the solar system's largest moon that quietly reorders the usual hierarchies. Ganymede, one of Jupiter's 4 large moons, known collectively as the Galilean moons after Galileo, who first observed them through a telescope in 1610, is larger than the planet Mercury. Not close in size, definitively larger, more massive, more voluminous, a moon that exceeds a planet. If Ganymede orbited the Sun directly rather than orbiting Jupiter, it would be classified as a planet without question. It has a diameter of more than 5,000 kilometers. It has its own magnetic field, the only moon in the solar system known to generate its own magnetic field, producing its own small auroras within Jupiter's vast magnetosphere. It has a complex, layered interior, an iron core, a rocky mantle, an icy outer shell possibly concealing a saltwater ocean beneath. It is a world, a full, complex, geologically interesting, magnetically active world. It simply happens to orbit Jupiter rather than the Sun. The category of moon, like most categories applied to the solar system, turns out to be less fixed than it initially seems. Ganymede is a moon, the way a river can be a road technically accurate for one purpose, and somewhat inadequate for fully understanding what it is. The solar system is full of things that exceed their categories, full of worlds that are more than they were first assigned to be. That seems worth remembering, about moons, and perhaps about other things too. There is a question about Earth's water that science has not yet settled, and the unsettled quality of it is part of what makes it wonderful. How did Earth get its oceans? The early Earth was hot. Formed from the collision and accumulation of rocky material, it was initially too warm for water to remain on the surface. Any water present would have vaporized into space. The oceans we have now must have arrived later, or survived from some source that persisted through the heat. One leading idea is that much of Earth's water was delivered by comets and asteroids, icy bodies from the outer solar system that, during the period of heavy bombardment, were flung inward by gravitational interactions with the giant planets and struck the inner planets repeatedly. The ice they carried, on impact, vaporized and entered the atmosphere, eventually condensing as the planet cooled into oceans. There is chemical evidence for and against this. The ratio of different hydrogen isotopes in Earth's water matches some types of asteroids more closely than it matches most comets, suggesting asteroids may have been the primary source. But the story is not simple or settled. Some of the water may have been here from the beginning, trapped in the rocky material that formed Earth, released by volcanic outgassing over millions of years. Some may have arrived from comets, some from asteroids. The oceans may be a mixture, a blending of water from multiple sources, assembled over hundreds of millions of years. The oceans you know, every sea and lake and river, every glass of water, the water in your own body right now, may have traveled here from the outer solar system, may have been ice on a comet once, drifting in the cold dark beyond Neptune, before something nudged it inward, and it found, eventually, this planet. Everything here has come from somewhere. You are part of a very long journey. There is a moon of Saturn so reflective it seems to reject the idea of being dark. Enceladus, with its constant snowfall from its own geysers, its fresh clean surface of water ice, its almost perfect whiteness, reflects about 99% of the sunlight that falls on it. An albedo of nearly 1. Almost no light is absorbed. Almost all of it bounces back. This makes Enceladus one of the coldest surfaces in the solar system, despite being relatively close to Saturn and therefore closer to the Sun than many outer moons. Because it reflects almost all incoming light, it absorbs almost no heat. Its surface temperature hovers around -200 degrees Celsius. A moon that is almost perfectly white, almost perfectly cold, actively covering itself in fresh snow from its own eruptions, maintaining its whiteness, continuously renewing the surface that might otherwise darken over time as space dust and radiation alter the ice. There is something almost meditative about Enceladus's whiteness, a surface that keeps itself clean, a moon that continuously returns to a blank state, covered in fresh snow erupted from its own interior, the dark of space, unable to permanently mark it. Everything that settles on Enceladus is eventually covered again. Everything that would stain or darken or alter the surface is buried under new snow. The past covered quietly, the surface renewed. White and cold and clean and still, a moon that rests in its own fresh snowfall, far away and unhurried, on the edge of Saturn's pale light. There is a quality to the view from Earth's surface that no other planet in the solar system offers, not in exactly this way, not with exactly this combination. The moon, as seen from Earth, appears almost exactly the same size as the sun, not approximately, not roughly, almost precisely. The sun is about 400 times larger than the moon in diameter, and it is about 400 times farther away. These two facts cancel each other out so precisely that from Earth's surface, the moon and the sun subtend almost the same angle in the sky. They appear the same size. This is why solar eclipses work the way they do, why the moon can slide in front of the sun and cover it almost exactly the disk of the moon fitting over the disk of the sun, with a precision that leaves only the corona, the sun's outer atmosphere, visible around the edges. A perfect fit, an apparent coincidence so striking that throughout human history it was interpreted as significance, as intention, as something meant. It is not permanent. The moon is drifting away, as we noted. Millions of years ago, it was closer and would have covered the sun with room to spare. Millions of years from now, it will be too far and will no longer be able to produce total eclipses, only the annular eclipses, where a ring of sun shows around the smaller, more distant moon. We happen to live in the era when the fit is nearly perfect, when the moon and sun appear, from Earth's surface, the same size. Whether that is coincidence or something else is a question the universe has left, characteristically, unanswered. But the view, the perfect darkening disk, the glowing corona, the sudden midday dark, is one of the most extraordinary sights available on this planet. And it will not always be available. It is a feature of this particular moment in the solar system's history, this window of time, which is, in some quiet way, a reason to be glad to be here now. The facts are gentler now, the information softer. We are moving towards something quieter than knowledge, something closer to feeling. Let the words carry you, rather than inform you. Let the solar system become, for these last stretches, less a place to understand and more a place to rest inside. There is a thought that arrives quietly when you have spent enough time learning about the solar system. Everything you have ever known, everyone you have ever loved, every moment of joy or difficulty or ordinary Tuesday afternoon, all of it has happened on a single planet, moving through space at an extraordinary speed, in a solar system moving through the galaxy at another extraordinary speed, in a galaxy moving through the universe at yet another speed. And through all of that motion, the spinning, the orbiting, the galactic travel, the cosmic drift, everything on Earth's surface feels completely still. You cannot feel the rotation. You cannot feel the orbit. The motion is real. Earth moves around the sun at roughly 30 kilometers per second, fast enough to cross the continental United States in under 3 minutes. And yet sitting still right now, you feel nothing of it. The stillness is perfect. The motion is perfect. They coexist without contradiction. This is not an illusion. The stillness is real. The motion is real. Both are true at once. Physics allows them both motion relative to the sun, stillness relative to the surface, both accurate, both present simultaneously. You are speeding through space at an extraordinary velocity, and you are perfectly, completely still. Both are true right now, at the same moment, in the same body. There is something in that particular combination, the vast motion and the perfect stillness coexisting, that belongs to this hour, to this quality of rest, moving through everything, held in place, both at once. There is a moon in the outer solar system, whose surface is the color of rust, and whose interior may hold an ocean, and whose name carries a weight of scientific excitement that its quiet, dark exterior does not immediately suggest. Europa. We have visited it in mind already, its global ocean, its icy shell, its more water than Earth. But there is another quality to Europa worth sitting with slowly. The surface of Europa is covered in lines, long, reddish-brown streaks crossing the white ice in every direction, curving and intersecting, layered over each other in patterns that suggest they formed at different times. Scientists call them linear lines, and they are thought to form when the ice shell flexes and cracks under tidal forces, the crack filling with warmer material from below that, then freezes at the surface. The reddish-brown color of the lines may be salts or organic compounds, or both material from the ocean below that has worked its way to the surface through the cracks and been altered by radiation at the surface. Europa's surface is, in a very real sense, a record of what is happening beneath it. The ocean below is expressing itself in the ice above, leaving traces, the internal activity writing itself onto the exterior in long curved lines, the way a life sometimes writes itself onto a face, not directly, not literally, but in the accumulated evidence of what has been happening beneath the surface for a very long time. What the ocean of Europa contains, we do not yet know, but it has been there, active and liquid, for billions of years. Whatever is in it has had time, enormous, quiet, patient time. There is a number that sounds like poetry and functions like geography. 100 billion. That is, the approximate number of planets scientists estimate exist in the Milky Way galaxy alone. 100 billion worlds, orbiting the roughly 100 billion stars of our galaxy. Some estimates place the number higher, several hundred billion, when you include planets that orbit in wide paths, rogue planets drifting between stars, and the small, dim worlds around the many faint red dwarf stars that make up the majority of the galaxy's stellar population. More planets than stars, more worlds than suns. In the galaxy we can see on a clear night as a faint band of light across the sky. Most of these planets we will never visit. Most we will never even detect. They are too small, too far, too dim to leave any trace in our instruments. They exist in quiet certainty, orbiting in the dark, undetected, unnamed, unobserved by any eye. But they are there, right now, hundreds of billions of them, going about whatever planets do when no one is watching, orbiting, cooling, or warming, being struck by occasional meteorites, having weather or not, sitting silent in the habitable zones of quiet stars, or boiling close to their suns, or drifting frozen in the outer reaches of their systems. The galaxy is not a place where stars occasionally have planets. The galaxy is a place where planets are ordinary, common, the natural consequence of stars forming almost inevitable wherever the right conditions exist. You live on one of hundreds of billions. That is not a diminishment. That is membership in something vast. There is a spacecraft that carried music, Voyager 1 and Voyager 2, launched within weeks of each other in 1977. Each carry a golden record, a 12-inch gold-plated copper disc, a message in a bottle thrown into the interstellar ocean. The records contain sounds: wind, rain, surf, thunder, the calls of birds and whales, the laughter of a child, greetings in 55 human languages, music. The music includes a Azerbaijani folk song, a Peruvian wedding song, a piece of Bach, Chuck Berry's Johnny Be Good, a Navajo night chant, a Pygmy Girl's initiation song, Beethoven. It was chosen to represent the breadth of human musical expression, not one tradition, but many, not one moment in history, but across time. The record also contains images, encoded in audio signals, images of Earth, of humans, of food, of architecture, of the solar system's structure. A portrait of us, sent outward in the hope that something, somewhere, might someday receive it. Neither voyager is likely to encounter another star system for tens of thousands of years. The golden record may never be found by anyone. The message may travel indefinitely through interstellar space, unreceived, unanswered, the music playing for no one but the dark. And yet the people who made it felt it was worth sending, felt that something traveling that far into the unknown should carry the best of what we are. Not a warning, not a claim, not a technical manual. Music, laughter, the sound of rain. Something of us is out there right now, carrying the sound of rain into the space between stars. That seems, in the quiet of this hour, like exactly the right thing to have sent. There is a planet in the solar system that has been visited only once by any spacecraft, and that single visit lasted only a few hours, and yet what was learned in those few hours reshaped our understanding of the outer solar system entirely. Neptune, Voyager 2, 1989. In those hours, Voyager 2 discovered 6 new moons. It found that the Great Dark Spot existed a storm the size of Earth. It measured the extraordinary wind speeds. It detected that Neptune radiates significantly more heat than it receives from the Sun. It confirmed that Neptune has rings thin, incomplete arcs of ring material, unlike Saturn's broad bands. And it revealed the extraordinary quality of Neptune's deep, saturated blue. All of that from a flyby, a craft moving past at tens of kilometers per second, gathering what it could in the brief window of proximity, then continuing outward toward interstellar space. Voyager 2 is still moving. It has now, like Voyager 1, crossed into interstellar space, the region beyond the heliopause, where the solar wind gives way to the interstellar medium. Both Voyagers are out there right now, still transmitting faint signals, still powered by the decay of radioactive material, still in contact with Earth, after nearly 5 decades of travel. Neptune, since that brief visit, has not been visited again. No spacecraft has returned. It remains, of all the planets, the least studied, the most mysterious, the one we know least about despite its size and its extraordinary qualities. It waits, blue and cold and active, tending its storms and its backwards moon and its strange heat source, attended by no instrument of ours, patient in a way that only something 4 billion kilometers away can be. There is something that happens to your perception of scale when you sit with the solar system long enough. The Sun contains 99.86% of all the mass in the solar system. Everything else, every planet, every moon, every asteroid, every comet, every grain of dust in every ring around every planet, is the remaining 0.14%. And of that 0.14%, Jupiter accounts for the majority. Jupiter alone is more than twice the mass of all the other planets combined, which means that Earth, this entire world, with its oceans and mountains and atmosphere, and every living thing that has ever existed on it, is an almost incomprehensibly small fraction of the solar system's total mass, a rounding error in the arithmetic of the Sun. And yet, the Sun, for all its mass, for all its overwhelming dominance of the solar system's material, cannot do what Earth does. It cannot have liquid water on a surface. It cannot have a sky that turns blue in the afternoon and gold at dusk. It cannot have a morning where mist lies in valleys. It cannot have a night where frogs call from ponds and stars appear, and someone lies down and lets the day go. Mass is not the measure of significance. The sun is immense and necessary, and the source of almost all energy in this system, and it cannot have an evening, cannot have a moment of quiet, cannot do what you are doing right now, resting, breathing, letting go of the day, drifting gently towards sleep. The rounding error gets to have the evening. The smallest fraction gets to have this. There is a quality to the light on other planets that, when you imagine it carefully, makes this planet's light feel like a gift. On Venus, the light at the surface is dim and orange, filtered through kilometers of acid cloud, arriving without direction, without shadow, without the quality of illumination that allows you to see the shape of things. Everything on the Venusian surface would be lit the way a room is lit, by a frosted bulb evenly, softly, without any clear source. On Mars, the light is thin and pink. The sun a smaller, paler disk than we know. The shadows long and lavender. The sky the color of a dusty afternoon that never quite becomes evening. On Titan, the light barely qualifies as light. A diffuse amber glow, orange filtered, without enough intensity to read by, without enough direction to cast a meaningful shadow. On the outer planets, the light is dim enough that human eyes, accustomed to Earth's sunlit surface, would struggle to navigate. And here, on Earth, the light is warm and gold in the morning, and blue and clear through the day, and amber and pink in the evening, and silver and soft when the moon is out. Shadows are sharp or gentle depending on cloud cover. The quality of light changes with the hour, with the season, with the weather, with the angle of the sun. No other confirmed world has light like this. This particular quality, warm, varied, golden, belongs to this planet and this distance from this particular star. The light here is extraordinary. It arrives every morning, and you have seen it so many times it has become invisible. But it is extraordinary, and it will be there again tomorrow. There is a process happening right now, deep in the interior of the sun, that is so fundamental to everything that exists here that it deserves a moment of stillness. In the sun's core, hydrogen nuclei protons are moving at velocities determined by the temperature of the core, which is about 15 million degrees. At that temperature, protons move fast enough to overcome the electromagnetic repulsion that normally keeps positively charged particles apart, and occasionally, rarely, by quantum mechanical probability, two protons come close enough to fuse. When they fuse, a small amount of mass is converted into energy, not much the mass of a few protons, but multiplied by the number of fusions happening every second in the sun's core, which is an almost incomprehensibly large number, the total energy released is enormous. The sun converts about 4 million tons of mass into energy every second. That energy begins its long journey outward through the solar interior, the million-year random walk through dense plasma we visited earlier, and eventually reaches the surface. Then it crosses 150 million kilometers of space in 8 minutes. Then it enters Earth's atmosphere. Then it reaches the surface. Then it falls on a leaf, and the leaf uses it to convert carbon dioxide and water into sugar. And something eats the leaf, or the sugar, and uses that energy to move, to grow, to live. And something eats that thing, and so on, through every food chain on Earth. Almost every living thing on this planet runs on energy that began as 4 million tons of mass, converted in the sun's core, carried across space, caught by a leaf. The leaf, the quiet, ordinary leaf, catching starlight, doing something ancient and precise with it, quietly feeding everything. There is a moon of Saturn whose appearance is so striking, so immediately arresting, that it was described by the scientist who discovered its surface coloring as the most bizarre object in the solar system. Iapetus, the third largest moon of Saturn. One hemisphere is almost perfectly white, as bright as fresh snow. The other hemisphere is almost perfectly black, as dark as coal. The contrast between them is one of the most extreme surface color differences of any body in the solar system. The dark material, called the leading hemisphere, because it faces the direction of Iapetus's orbital motion, accumulates there because Iapetus is tidally locked, one face always pointing forward in its orbit, and sweeps up dark material as it travels. Some of this material comes from the outer moons of Saturn, dust knocked off by micrometeorite impacts drifting inward. Some may be altered by radiation. Some may be intrinsic. The white hemisphere is water ice, clean and bright, maintained in its brightness by the same tidal locking that keeps the dark side perpetually facing forward. The ice is too cold to be altered the same way. Two hemispheres, one world, as different from each other as anything on the same body can be. There is something in Iapetus's extreme division, that hard line between dark and light, between black and white, between the face that sweeps up the dark and the face that stays clean, that feels like a particular kind of honesty. A world that does not smooth over its contradictions, that simply contains both, side by side, without resolution. Most things worth knowing contain both, side by side, without resolution. And that is not a flaw. That is just what it means to be a real thing in a complicated universe. There is a fact about the solar system that feels, at this hour, less like information and more like something to carry into sleep. The planets are ancient. The sun is ancient. The rocks beneath you are ancient. The atoms in your body are ancient, beyond any meaningful comparison to human time. And the solar system is, by current scientific understanding, approximately halfway through its life. The sun will continue to shine, roughly as it shines today, for another 5 billion years. The planets will continue to orbit. Earth will continue to turn. The moon will continue to drift slowly outward. The seasons will come and go. 5 billion years of morning light still to come. 5 billion years of tides. 5 billion years of weather and seasons, and the slow movement of the continents, and the long, quiet cycling of water through sky and ocean and ground. In the context of all that time, all that vast, unhurried future tonight, is one quiet evening among an almost unimaginable number of quiet evenings still to come on this planet. One night among billions, and you are in it, present in it, resting in it. One person on one planet on one evening in a solar system that has 5 billion years of evenings still ahead of it. There is no urgency in that picture. There is only continuance. The gentle, reliable, ancient continuance of a solar system that has been doing this for a very long time and intends in every way we can measure to keep doing it for a very long time more. Rest, then. The planets have this handled. They have always had this handled. They will still be turning when you wake. The words are slower now, the sentences softer. We are very close to the edge of sleep, and the facts that remain are less facts than they are feelings dressed in the clothes of science. Receive them gently. Let them arrive the way light arrives through a window at dusk, not demanding attention, just present. There is something that happens when you hold a stone. Any stone, a pebble from a path, a river rock smooth from water, a piece of gravel from a driveway. The stone is made of minerals, and the minerals were formed by geological processes that took millions of years, and the elements those minerals are made of were forged in ancient stars that lived and died before the sun existed. Every atom in that stone passed through a star. Every atom in your body passed through a star. The calcium in your bones, the iron in your blood, the oxygen you are breathing right now, all of it was manufactured in stellar interiors, or in the violence of stellar deaths, scattered into space, gathered by gravity into clouds, collapsed into a new star and its planets, and eventually assembled, over billions of years of chemistry and geology and biology, into the specific form of a specific person, lying somewhere specific on a specific evening. You are not separate from the universe. You are not a visitor to it, looking at it from the outside. You are made of it, assembled from its oldest materials, running on energy, borrowed from its processes, breathing its atoms in and out, returning them to the air where they will be breathed by something else, used by something else, cycled through the world long after you have finished with them. The universe is not out there. It is what you are, right now, in this moment, in every breath. There is a frequency at which the planets of the solar system vibrate not in sound, which requires air to travel, but in electromagnetic frequencies. NASA has translated some of these frequencies into audio, shifting them into the range human ears can detect. Jupiter sounds something like deep, resonant thunder, with high, eerie tones moving through it. Saturn produces something that has been described as haunting, long, sustained drones with shifting harmonics, caused by radio waves generated in its magnetosphere interacting with its rings and moons. Earth's magnetosphere produces a sound called chorus, a rising bird-like chirping that occurs when charged particles interact with the magnetic field, which is one of the stranger and more beautiful things to know about the planet you live on. The sounds are not music in the intentional sense. They are not composed. No one arranged them. They arise from the physics of each planet from magnetic fields and charged particles and electromagnetic interactions translated into something a human ear can receive. And yet they are not random. They have character. Jupiter sounds large and turbulent. Saturn sounds vast and strange. Earth sounds, in its magnetospheric chorus, almost like something alive rising, repeating patterns that would not be out of place in a recording of birdsong at dawn. The planets are not silent. They speak in frequencies we cannot normally hear, in languages made of physics rather than intention. And when we slow down enough to listen, when we translate the signal into something our ears can receive, what we find is that the solar system has been making something that resembles music all along, quietly, for billions of years, without any audience. Until now. There is a process happening right now, on every rocky body in the solar system, so slow it is imperceptible to any instrument, and yet so certain that it is simply a matter of time. Every planet is cooling. The Earth's interior is still hot from its formation, the energy of the collisions that built it, still present, slowly radiating away into space. It is also heated by the decay of radioactive elements, uranium, thorium, potassium, which release energy as they break down, warming the rock around them. This internal heat drives the convection of the mantle, which drives plate tectonics, which drives the geological activity that keeps Earth dynamic and self-regulating. But it is slowly diminishing. Over billions of years, Earth's interior will cool. The radioactive elements will decay completely. The mantle convection will slow and eventually stop. Plate tectonics will cease. The magnetic field will weaken. The geological renewal of the surface will end. This is not imminent. It is billions of years away, and the sun will change before Earth's interior goes cold. But the process is real and ongoing. Right now, beneath your feet, heat is slowly leaving the planet. Imperceptibly slowly, but leaving. The Earth is a cooling ember, warm and active now, in the middle of its long geological life, still moving and renewing and dynamic. But slowly, over time, that makes all of human history feel like a moment, cooling towards stillness. And in that cooling, there is something strangely peaceful. The idea of a world doing its work for billions of years, then slowly, gently, resting, taking its time, in no hurry. The way everything, eventually, finds its stillness. There is a planet in the outer solar system, one we have visited only in thought tonight, one that will likely not receive a dedicated spacecraft for many years, that holds, in its unvisited quality, a particular kind of wonder. Uranus has 27 named moons, each one named after a character from literature, each one tumbling in its own orbit around a tilted planet in the cold and dim outer solar system, carrying a name that came from a human imagination in a specific room on a specific evening centuries ago. Miranda, Oberon, Titania, Ariel, Umbriel, names that belong to plays performed by candlelight, to poems read aloud in drawing rooms, to stories told between people who had no idea that their characters' names would one day travel to the outer solar system and be given to moons of ice and rock, orbiting a gas giant 2.7 billion kilometers from the Sun. Miranda, in particular, the smallest of the 5 large moons, has a surface that suggests it was shattered by a massive impact long ago and reassembled from its own fragments. The result is a moon of extraordinary geological confusion. Cliffs 10 times taller than the Grand Canyon, canyons, and ridges in improbable combinations, a surface that looks like it was put back together by something that was not quite sure of the original arrangement. A shattered moon, reassembled, carrying the name of a character who says, in Shakespeare's Tempest, the most famous expression of wonder in the English language, a speech about the beauty of humanity, about seeing the world as full of remarkable creatures. The moon named for wonder has the most astonishing surface. The universe, as always, does not intend these things. And yet, there is a quality to the search for life beyond Earth that has shifted, quietly but significantly, in the last few decades. It used to be a question of whether other planets could possibly harbor life, a largely theoretical inquiry, based on what we knew of Earth, and very little else. Now it is a question of where, and in what form. The discovery of extremophiles organisms on Earth that thrive in conditions once thought entirely hostile to life has expanded the definition of habitable. Life has been found in acidic hot springs, in ice sheets, in the crushing pressure of the deep ocean, in the radioactive cooling water of nuclear reactors, in clouds of sulfuric acid, similar to those on Venus. Life on Earth has explored almost every available environment and found a way to persist. The discovery of liquid water oceans on Europa and Enceladus, of organic chemistry on Titan, of complex molecules in interstellar space, all of it has shifted the question from possibility to probability. The ingredients are there, in multiple places, in this solar system alone. We have not found life beyond Earth. That remains true, and it is important to hold that honestly. But the absence of discovery is not the same as absence of life. It may simply be that we have not yet looked in the right place, with the right instrument, at the right moment. And we are looking. Telescopes scanning exoplanet atmospheres for chemical imbalances that biology might produce. Spacecraft en route to Europa. Future missions planned for Enceladus. The search is active and genuine and patient. Somewhere, in this solar system or beyond it, there may be something quietly alive, going about whatever it does, entirely unaware that anything on a small blue planet is looking for it. The universe may be full of beginnings. We are one of them, and we are paying attention. There is a thought that arrives, in the quietest part of the night, as something close to a feeling. The solar system is moving through the Milky Way. The Sun, carrying all its planets with it, orbits the center of the galaxy, a slow, vast orbit that takes about 225 million years to complete. In the time since the last dinosaurs walked on Earth, the solar system has not completed even one full galactic orbit. In the entire history of complex life on Earth, we have gone around the galaxy perhaps twice, and the galaxy itself is moving, part of a local group of galaxies, all drifting together toward a region of space called the Great Attractor, a massive concentration of matter whose gravity draws everything in this corner of the universe toward it. Everything is in motion. Everything has always been in motion. The ground beneath you is on a planet orbiting a sun, orbiting a galaxy, moving through a universe that has been expanding since its beginning. And right now, you are still. Not because motion has stopped, because stillness and motion are not opposites, because you can be carried by something vast and remain, in your own particular center, perfectly quiet. The way a seed is still inside a fruit that is falling, the way sleep is still inside a night that is moving through space. You are being carried right now by the planet, by the solar system, by the galaxy, by the expansion of the universe itself, all of it moving, all of it vast, and you, inside all of it, resting, carried, and still, both true, both real. There is a planet that was discovered by mathematics, and a moon that was discovered by accident, and a ring system discovered by the dimming of a star, and an ocean discovered beneath ice by the flexing of gravity. Everything in the solar system has its own story of being found, its own moment when it crossed from unknown to known, from darkness into the light of human attention. And there is something in that, in the accumulated history of discovery, of patient watching, of careful inference, of instruments trained on the sky for decades, that says something about what it means to look for things, to believe things exist before you can see them, to trust that the universe is more than what is currently visible. The solar system is not finished being discovered. New moons are still being found around the outer planets every few years. The Kuiper Belt and Oort cloud still hold countless objects we have not detected. There are likely planets in other star systems so similar to Earth that if you stood on them you might not immediately know you were somewhere else, and we have not yet found them clearly, though we are looking. The universe keeps more than it reveals. It gives up its details slowly, to careful attention, to patient instruments, to questions asked with enough precision and enough humility to receive an answer that is stranger than expected. You are living in a period of extraordinary discovery. More is known now about the solar system, about exoplanets, about the structure of the universe, than at any previous moment in human history. And this is still the very beginning. The instruments are still being built. The missions are still being planned. The questions are still being formed. The solar system is not done surprising us. It has been doing this for 4.6 billion years, and it intends to continue. There is a number 101 that we have arrived at together, you and I, across this long, quiet night. 101 facts about planets. 101 soft landings in the vast and quiet solar system. 101 reasons to feel, if not small exactly, then appropriately sized. Part of something much larger than a single life, a single planet, a single evening. And the facts are done now. The information has given way to something else, something that doesn't need a number. The planets are still out there, right now, as your breathing slows, as the day releases its hold on your mind. The solar system is continuing its ancient, reliable work. Saturn is spinning faster than you can easily imagine. That enormous pale planet rotating in under 11 hours, its rings catching the faint sunlight, each particle on its own quiet orbit. Mars is turning slowly in its rust-colored day. The sun a pale disk in a pink sky. No wind tonight in Valles Marineris, the ancient canyon walls standing in their billions of years-old silence. Jupiter's great red spot is rotating, as it has been rotating since before your great-great-great-grandparents were born. The amber cloud moving in its ancient circle, the planet's magnetic field, reaching millions of kilometers into space. Enceladus is erupting its plumes of water vapor quietly into the dark near Saturn, adding its small contribution to the E-ring, tending its hidden ocean, going about its business, as it has done for billions of years. And Neptune is there, blue and cold and active, its backwards moon Triton moving in its slow retrograde arc. The faint signal from Voyager 2, long since passed beyond it, the planet alone now, with its storms and its mystery, and its 165-year patience. All of this is happening right now, while you rest, while your eyes are closed or closing, while the day's last thoughts are dissolving into something less structured and more free. The solar system does not pause. It does not wait for us to pay attention. It does not need our observation to continue its work. The planets were turning before any eye existed to watch them, and they will be turning long after the last eye closes. But for a little while tonight, for these hours of quiet travel through facts and images, and the slow, poetic accumulation of a sense of where we are, you paid attention. You let the solar system be large, and you let yourself be a small resting thing inside it. You let Jupiter be vast, You let Pluto be cold and far and heart-shaped. You let the sunlight on your skin carry its million-year history. You let the ocean's depth be real, and the canyon's silence be real, and the water on Enceladus be real, and the blue of Neptune be real. And in that letting, something happens, something quieter than knowledge and larger than information, a sense of belonging that doesn't require you to be big. That only requires you to be here, present, breathing, part of the same universe that makes gas giants and frozen hearts on distant worlds and water that cycles endlessly through sky and sea and the bodies of living things. You are part of it. You have always been part of it. You were never separate from it, not even for a moment. Even as you rest right now, atoms that were once part of ancient stars are resting with you. The universe, in the most literal sense, is lying down. The earth is turning beneath you, slowly, at just the right speed to carry you from night back into morning. Somewhere on the other side of the planet, it is already dawn, the same sun, the same light, arriving fresh on a different face of the same world. The moon is out there, drifting its inch and a half further away, patient and silver and old. The tides it raises in the ocean are moving somewhere right now, water responding to something that is 380,000 kilometers away, the whole ocean of Earth, in a slow, lunar conversation. And the stars, the ones you might see if you went outside, if the sky is clear and the clouds have moved on, those stars are suns, each one, some with planets in their habitable zones, receiving just enough light, just the right warmth. Some of those planets may have water. Some of that water may have something moving through it. We do not know. We are looking, and in the meantime, we are here, on this particular water-covered world, in this particular night, breathing this particular air that has been breathed by every creature that ever lived on this planet, and will be breathed by every creature that comes after. The air is shared. The night is shared. The universe is shared. You are not alone in it. You were never alone in it. You are held by it, made of it, return to it with every breath. Let the solar system recede now. Let the planets become, not information but a feeling. The feeling of being somewhere small and real inside something vast and ancient and continuing. Let Jupiter become a sense of scale. Let Saturn become a sense of beauty. Let Europa become a sense of possibility. Let Pluto become a sense of distance. And let the heart on its surface be exactly what it looks like, something gentle, found where you least expected it. Let the sun become warmth. Let the moon become familiarity. Let Earth become home, not because it is the only possibility, but because it is yours, because you are on it right now, because it is holding you, as it has always held you, as it will hold you through this night and into the morning that is already, quietly, on its way. The morning is coming, carried by the rotation of the planet you are resting on, inevitable and gentle and unhurried. The sun is already illuminating the other side of the world. The light is traveling. It will arrive, but not yet, not yet. For now, there is only this, the night, and the planets turning in it, and you, resting inside the solar system, as you have always rested inside it, whether you knew it or not, carried, still, breathing. The facts are finished. The wonder continues. It always continues.